College is often viewed as a mere institution, a labyrinth of classrooms, textbooks, and endless exams, where our future is shaped. Yet, when we step foot on campus, we realize that we are not alone on this journey. University transcends academia, transforming into a vibrant community where individuals unite to learn from one another, to grow and to forge unforgettable bonds. It's not always about having a precise plan. It's not always about figuring out. It's not always about reaching the finish line first. It's about discovering what we are truly passionate about. The true essence of college, however, lies beyond the confines of academic pursuits. What truly makes college so special is the life that's lived within its walls. It's about seeing things from different perspectives, exploring unique possibilities, taking on new challenges, finding joy in friendship, embracing individuality, expanding our knowledge and skills, and immersing ourselves in extraordinary experiences. It's a path that teaches us about resilience, courage, and determination, a quest that allows us to pursue our goals with purpose and clarity, a quest that helps us find balance, happiness, and fulfillment. A transformation that inspires us to live with intention, curiosity, and joy. A trail that leads us to a deeper understanding of who we are and what truly matters. It's a journey of self-discovery, where every experience shapes us into the best version of ourselves. The college for education, what we live, is a treasure trove of experiences that shape us forever. Experience a whole new world of academic excellence in a global environment. University, inspiring future trailblazers today.
Good afternoon, students. Welcome to Daya. Today, you are going to have chemistry class 4 to 5:50, 5:50 to 6:05 break, 6:05 to 8, you are going to have biology class. Chemistry topics are going to be solids and solution, P block and elements and chemical kinetics. I request Ravi Shankar sir to take over the session, sir. Dear students, if you have any doubts, put in Q&A box. Sir will check Q&A box and answer your queries. Is it okay, sir?
Yeah, no problem.
Okay. Thank you so much. The screen is visible, sir.
Yeah, right. So, dear students, welcome back to Daya. In my last class, I was discussing about solids. We will take a few more questions of solids, then move on to solution, and then to P block. Okay. So, Schottky defect in a crystal is observed when we know that when equal number of cations and anions are missing. Okay. Just a minute. Just give me a minute. I just open a file. Just give me a minute. Just have to take my file. It is loading up. Yeah, I got it. Just a minute. So the correct statement regarding this defect in solid is, what may be the answer? I'll just take a pen. Schottky defect has no effect on the physical property of a solids. So what may be the answer? Yes, Schottky defect has no effect on the physical property. Because he says we have to select a correct one. Is it a right answer then? But we know that in Schottky defect, what will happen? The cations and the anions are missing. When they're missing, what will happen? The density will decrease. So density decreases. Density decreases. He says there is no physical effect. So A cannot be the option. Then we will go to B. So Frenkel defect is a dislocation defect. He says Frenkel defect is a dislocation defect. Yes, sir. What is happening? Here, they occupy interstitial space. Interstitial space. So they move from lattice point. They move from the lattice point and the particle is present in the interstitial space. So it's a dislocation defect. So this may be right. Let us check it out. See, Frenkel defect is usually found by very small difference in the size of cation and anion, he says. This is wrong, sir, again. There should be large differences. So option C is wrong. Then D, trapping of proton in the lattice leads to the formation of F centers, he says. Wrong, sir. It is the trapping of electrons in F center is what leads to formation of F center. So option B is right, sir. Option B is right. Next. So which of the following crystal has a unit cell such that the bond length ABC is not equal, whereas the bond angle alpha, beta, and gamma is also not equal to 90? What may be the option? So I told you about 7 crystal system for you. Bagri sir, is it video? Is not visible?
Yes, sir. It is
Okay,
visible.
great. So if you look at this one, I told you about 7 crystal system for you. And this 7 crystal system is based on the parameter of the bond length A, B, C, and the bond angle alpha, beta, and gamma. So this value where it is not equal to 90 and both of these bond length are not equal represent triclinical system. So triclinical system. And this kind of triclinical system is exhibited by crystals of dichromate. Which are the dichromate here? Sir, potassium dichromate, 0%. So it has to be option A. Next one. Yeah, Dhrani, tell me. Dhrani, what you can do is that, Arsha, Aditya, they're asking some doubt, Dhrani and everything. Sir, how to remember this one? Remember, I'd given you, okay. Wait, I'll just take this one. I have given you in a, look at here, Dharani and Arsha. Remember this. This is the slide I told you where I have classified the solids into 7 systems. Sir, how to remember these ones? I told you very simple. If it is equal, it is a clinical system. And if it is not equal, it is a triclinic system. Tri system. Please remember this one. And if all bond lengths are not equal and bond angle is equal, then it is orthorhombic. Orthorhombic. And if all of this, both bond length and bond angle is not equal, so it's a triclinic. I'll go to the next question. This one. That's question number 15, 16. Oh, no, this is done. Then 17. So this already we have done. In a face-centered cubical element, A is present at the corner. A corner of the unit cell. B are at the face, he says. B are at the face. One of the A atom is missing. That's why we have taken test 7. 7 into 1 by 8 is 7 by 8. And B atoms are face-centered. So 1 by 2. That means it is shared by 2 unit cells. So the ratio is 7 by 8 into 3. That is 7 is to 24. So which of the following oxides shows electrical property like a metal? What may be the option? Which of the following crystals shows a property which is similar to a metal? We know that when solids can be classified based on electrical property into what? Insulators, conductors, and semiconductors. Semiconductor. So which among these following crystal can show a property similar to the metal? Among these chromium oxides. Chromium oxide means what? So the option D, CrO2, can have a property similar to that of metal. Next one. So in a face-centered cubic system, the unit cell is shared equally by how many unit cells? Sir, how many unit cells? Each unit cell in a face-centered cubic system is shared by how many? Sir, on four sides you have 4 unit cells, and the front and on the back you're having 2 more unit cells. There are totally 6 unit cells are surrounded. That means, sir, option C. Edge length of a cube is 300 picometer. Its body diagonal would be, what would its body diagonal, sir? What is the body diagonal? I already told you. In a crystal, body diagonal means you are having a 3 particles. So you are having a 3 particles. How it will be? So from one corner of this into opposite corner, you'll be having a body diagonal axis, where you'll be having a 3 particle. And if you take this particle as a spherical shape, I told you, half of the spherical sphere is R, and then this complete sphere means diameter, that is 2R, and another half sphere means R. That is, sir, 4R is equal to square root of 3A. Square root of 3A. So square root of 3 into A means what they have given, say is given 300 picometer. 300 picometer. Square root of 3 means, so around 1.7 into 300. So it comes to around 519. 19. Means what is the option? Sir, option is C. Yes, sir, option is C. What we got is right. Which of the following is not a conductor of electricity? Is not a conductor of electricity. Again, I told you the classification of solid based on conductivity into what? Insulator, conductor, and semiconductor. Copper is a metal, so it's a very good conductor. And fused NaCl means what? Fused NaCl means molten NaCl. Molten NaCl means you're having Na plus ion. You're having Na plus ion. And when there is ions are there, they conduct electricity due to migration. So due to migration of ions, there is a conductivity. What is a brine? Brine is nothing but again a solution of NaCl. Solution of NaCl. That means you are having again Na plus and Cl minus ion. When ions are there, there is a migration. When there is a migration, then there is a conductivity. So all these 3 conducts are. But whereas in solid sodium chloride, there is no ions. There is no ions. So no conductivity, sir. The option has to be yes, sir. Options to be. Which of the following is a network crystalline solid? So what is a network crystalline solid? We classified the solid based on what? 3 criteria. So solids can be classified based on 3 criteria. Which are those? The first one is based on conductivity. or we can call it electrical property. Then based on, there's one more classification based on magnetic property. Then one more classification is there that is based on types of particle. So type of particle in LA in lattice points. In lattice point. Right. So based on this particle in lattice point, we have an ionic solid, we have a molecular solid, we have a covalent solids, and metallic solids. So here says network crystalline solid. Sir, iodine cannot be. And sodium chloride is ionic solid. Sodium chloride cannot be. Ice is cannot be, sir. It's a molecular solid. So the network crystalline solid is only aluminum nitride. That means sir, option B. Next one. The number of atoms in a 2.4 gram of body center cubic crystal with a edge length of 200 picometer. Density is given. Avogadro number C is given. We have to calculate number of atoms. So how to calculate? He has given density. And we know that density is equal to what? So density is equal to number of particle Z into M molecular mass divided by edge length A cube into Avogadro number. So what we have to find out now then? To find out the number of atoms, first we have to find out molecular mass. Molecular. So how to find out? Then the molecular mass is equal to M is equal to density. So into A cube into Na divided by it becomes Z. So density is given. How much is given density? So he says 10 gram per cm cube. That's right, 10 gram per cm cube. A cube is given, sir. How much? 200 picometer. That is 200. If you convert into centimeter, 10 to the power of 10. How many times? 3 times, sir. Into Na, Avogadro number 6.02 into the power of 23. So divided by Z. Z is 2, sir. He says body center. Number of particle is 2. So how much we get? So what may be the value? So it comes to around 24 gram per mole. If 24 gram contains 6.02 into 10 to the power of 23 atoms. 23 atoms. He says what? 2.4 gram he says. 2.4 gram contains how many? That is X is equal to, sir, 6.02 into 10 to the power of 23 divided by 24. Into what? We get 2.4 here. 2.4. So this becomes how much? This we can write it as 2.4, 2.4 gets cancelled. And this becomes 6.02 into 10 to the power of 22, sir. 22 means what is the option? Sir, option is A. A is the answer. A is the answer, sir. One mole of sodium chloride is doped with 10 to the power of minus 5 moles of strontium chloride. The number of cationic vacancies in the crystal lattice will be. So how many cationic vacancies will be there? In a sodium chloride crystals, the cation Na plus occupies a lattice point and Cl minus occupies another lattice point. So when you introduce strontium, strontium is having a 2 plus charge. And this strontium, since it's having 2 plus charge, it can introduce one cationic vacancy. Each strontium can introduce one cationic vacancy. Then you say how much you're adding is doped with 10 to the power of minus 5. 10 to the power of 5 minus 5 mole of strontium chloride. Means you're adding 10 to the power of minus 5 mole of strontium 2 plus. Strontium 2 plus. So how much it becomes? So 10 to the power of minus 5 into each mole contains how many? 6.02 into 10 to the power of 23 particles will be there. In every 1 mole, this many particles will be there. So you're introducing 10 to the power of minus 5 moles of strontium. So the cationic vacancy will be 6.02 into 10 to the power of 18, sir. What will be the option? Sir, option is again A. Next one. A metal exists as an oxide with a formula M0.96O. Metal can exist as M plus 2 and M plus 3 in its oxide. The percentage of M plus 3 in the oxide is, how much it will be? So how much it will be? He is asking percentage of M plus 3. So how to solve this one? He has given metal oxide. What is the metal oxide he has given? M is 0.96 and O is given. Let us take O as 100. O as 100. So the number of O2 minus ion, so is equal to 100. M plus 2 we don't know, sir. Let us take it as X. Let's take it as X. So how much M plus 3 will be there? Then M plus 3 will be 96 minus X. Because already metal is given 0.96. 96 minus x. And in a solid, always there should be electrical neutrality. Solid should be neutral. When solid should be neutral, the positive charge should be equal to negative charge. Should be equal to negative charge. Then this, let us take it as the positive charge, m plus 2 means plus 2, 2x, let us take it as 2x plus 96 minus x. What is 96 minus x? M plus 3 is equal to how much? The m plus 3 means, let us take it as 3 into 2 into 100. So how much it becomes? So it becomes 2x plus 288 minus 3x is equal to 200. Or we can say x is equal to what? 88, sir. Then how many m plus 3 is there? So the number of m plus 3 is equal to, we already know, 96 minus x. What is the x? 88, sir. Then we get 8. The percentage means, the percentage of m3 plus means, sir, 8 by 96 into 100. It is almost around 8% it comes. 8% means, sir, option is D. Option is D. Yes, sir, option is D. Next one. A metal crystal is in a face-centered cubic structure with a metallic radius of 2a, square root of 2 Armstrong. The volume of the unit cell is, what is the volume of this unit cell? In a face-centered cubic system, so in a face-centered cubic system, we know that one. A is equal to what? So A is equal to 2 into square root of 2r. He has already given radius. What is the radius? A is equal to 2 into square root of 2. So what is the radius he has given? Radius is equal to square root of 2 Armstrong. So into square root of 2 will do. How much it becomes? So it becomes a 4 Armstrong. If you convert into meter, it becomes 4 into 10 to the power of minus 10 meters per meter. And we know that volume, when you say volume of unit cell, is always equal to a cube. So what is a cube then? 4 into 10 to the power of minus 10 whole cube. It becomes how much? So it becomes 64 into 10 to the power of minus 30 meter cube. And this can also be written as 6.4 into 10 to the power of minus 29 meter cube. That means our option is A. Option is A. Check it out. Option is yes, sir. Silicon doped with gallium forms what? I told you solids can be classified as a semiconductor. And in that semiconductor, I told you there are two types. So one is N-type. What is N-type? When silicon is doped with group 15. So what is P-type? So P-type is when silicon is doped with group 14. Okay. Group 13. When is doped with group 13. What is group 13? Sir, boron family. Boron family. Which are boron family? Sir, boron, aluminium, gallium, all those elements. All those elements. So when you dope with gallium, sir, we get P-type semiconductor. So option is C, sir. Option is C. Next one. So this is the question appeared in 2021. In case of beryl, compound containing beryllium, aluminum, and oxygen, oxide forms cubical closed packed structure. Aluminum occupies Aluminium ion occupies 1/4 of tetrahedral whites, and beryllium occupies 1/4 of octahedral whites. The formula of the compound is so there are three elements: beryllium, aluminum, and oxygen. What may be the option? So let us take three elements. Here are three elements. Sir, we have beryllium, then we have aluminum, then we are having oxide ion. He says oxide ion forms cubical closed packed structure. So this is the number of ions involved in the cubical closed packed structure. N, let us take it as N. Aluminum occupies 1/4 of a tetrahedral whites. If the number of particles is N, tetrahedral white is always double. That means 2N it is. But he says 1/4, that is 2N/4. And beryllium occupies 1/4 of octahedral. Octahedral is, if the number of particles is N, octahedral whites are N. Again, he says 1/4. Let us take it as N/4. N/4. So what is the ratio? The ratio becomes what? Sir, 1:2 it becomes. That means beryllium Al2O4. Al2. So what is the option then? See, the option becomes B, sir. Because always octahedral weight is equal to number of particles. Always remember, if the number of particles is 2, octahedral is also 2. But tetrahedral also, it becomes twice, 2 into 2. Next one. The correct statement regarding defect in a solid is, what is the correct statement about defect in a solid? So Frenkel defect is a vacancy defect. So Frenkel defect means what? So where one cation is missing from its lattice point. But it has not gone anywhere. Where it has gone to the interstitial space in the solid only. So it is there in the solid itself. So it is not a vacancy defect. It is in fact a dislocation defect called as. So here cannot be the answer. Schottky defect is a dislocation defect. It is a vacancy defect. Why, sir? The cation and anion are missing. And anion are missing. So B cannot be. Trapping of electron in a lattice leads to F center. Yes, sir, that is right. Let us see D. Schottky defect has no effect on density. No, sir. Here both cation and anion are missing. When they're missing, density decreases. Density decreases. So it cannot be D also. The option is C, sir. Next one. A metal crystal is in a BCC lattice. With a unit cell edge length of 300 picometer and density of 6.15 gram per cm cube, the molar mass of the metal is. This already we have done. What is molar mass? We know density. What is density? So density is equal to Z into M divided by A cube into Na, sir. And what we need to know, we have to calculate M. M is equal to, it becomes density into A cube into Na, Avogadro number divided by sir Z. So what is the density they are given? So they are given 6.15. Sir, A cube, how much they are given? 300 picometer. Means if you convert into centimeter, it is minus 10 centimeter per cube. This is twice we have to write. Into Na, so 6.02 10 to the power of 23. So divided by 2 we got this. How much it will be? So it comes to around 50, that is 50 gram per mole. 50 gram per mole means, sir, option A. Next one. Question number 30. Vacant space in a body-centered cubic lattice unit is. What is the vacant space? So in body-centered cubic system, the packing efficiency is how much? 68%. So 100 minus 68%, sir. That is equal to 32%. Sir, how many number of atoms are there in a cube-based unit cell having a one atom on each corner and two atoms on each body diagonal cube? Notice, these kind of questions is common in almost every year and easy to do. He's just asking how many number of atoms are there in the cube-based unit cell. One atom in each corner. So he says one atom in corner. And how many corners? So there are 8 corners. Into 8 into 1 by 8 is equal to how many? 1, sir. And it's a body diagonal. And he says it's a body diagonal. And he says 2 atoms on each body diagonal of cube. 2 atoms, he says, in BCC. In BCC, number of particles is how much? 4. That is 4 into 2. So it is 8. So the total atoms means the total atom is equal to, sir, it is 8 plus 1. That is, sir, 9. What is the option? Sir, option is B. Option. Which of the following is not true about amorphous solids? Amorphous solids. So amorphous solids can be molded by heating. That is right. A is right. Let's come to B. Sir, they are anisotropic. That is wrong, sir. They are isotropic. Isotropic. What is isotropic? From any angle, if you measure the physical property, okay, it is almost same. It is almost same. So that is not true. So that will be the answer. Next one. Alkali do not show dislocation defect. Why? Do not show dislocation defect. That means Frankel defect. Why they do not show different dislocation defect? Alkali halides. He says anions cannot be accommodated in a vacant space. Wrong, sir. Because it is the cation which move from lattice point to interstitial space. So that cannot be. They have a low coordination number. Wrong, sir. There's a large difference. There should be small difference. So that is wrong. So option should be, sir, yes, sir. Next question. We'll take one question from NEET also. This is from NEET. Then we'll move on to solutions. Compound is formed by cation C and anion A. The anion forms hexagonal close packing. Hexagonal close packing. And the cation occupies 75% of octahedral. Already told you. If number of atoms per unit cell, I'll remove it. If number of atoms per unit cell Sir, how much? In SCP, sir, it is 6 cities. 6. That means then number of octahedral void is also will be 6. Tetrahedral would be double. He says 75% of octahedral. 75% octahedral means 6 into 75 by 100. That is 9 by 2. 9 by 2. So the cation, which is the cation here? C. This is the cation C. So C is 9 by 2. And what about anion, sir? He says anion forms hexagonal close packed lattice. Lattice. How much it is? So it is 6 only. A6. So it is C 9 by 2 and A6. A6. So what it will be, if we simplify it, it becomes C3A4. C3A4 means what should be the option? So D will be the answer. So all these things we have already done, so let us not take it up. We'll move directly to topic solutions. So in solution, what are the things we have to study? You know that solution means it's all about solute present in a solvent. So what is solubility? Solubility is all about what? A amount of substance or a solute dissolved in a solution. We call solvent, we call it as a solution. So in a solution based on physical state, we have a gas in gas, gas in liquid. Okay, likewise we have liquid in gas, liquid in liquid, and solid in gas, solid in liquid. These are the different types of a solutions what we are having. So based on concentration, we can say diluted, concentrated, saturated, and supersaturated, and all those things we can know that. And how to express the concentration of solution? Mainly mass percentage. Mass by total mass into 100. Then we call it as molarity. What is molarity? It is the 1 gram molecular weight. Sir, in 1 liter. So 1 gram molecular weight in 1 liter. We call it as molarity. Or he says number of moles of solid by volume of solution. We can write it as what is number of moles? Sir, mass by molecular mass into volume means 1000 by V, sir. We can write it like this also. And always remember, for monobasic acid and monoacidic base, molarity is always equal to normality. Why, sir? Because molecular weight is equal to equivalent weight. Is equal to equivalent weight. So what is molality? Molality is nothing but number of moles of solute in solvent in kg. What is normality, sir? Normality is number of gram equivalent weight of solute in volume of the solution. That means what? So 1 gram equivalent weight in 1000 times. So what is a mole fraction? You know, the number of moles divided by total number of moles. Volume percentage, volume by total volume. ppm, so number of parts by total number of parts into 10 to the power of 6. So mass by volume, that is volume mass by total volume into 100. And remember, mass, percentage, ppm, mole fraction, and molarity are independent of temperature. Next one. The solubility of a given solute in a solvent depends on what? So depends on nature of solute, nature of solvent, temperature, and pressure. If you take a solubility of a solid in liquid, sir, here usually we say polar substance dissolved in a polar solvent. And what is the effect of temperature? So in case of exothermic process, there is an increase with rise in temperature. So in an endothermic process, it is a decrease with rise in temperature. So what is the solubility? And in case of solid, a pressure have no effect. Remember, in solid, a pressure have no effect. And in case of gas in liquid crystal, if it is a solid, the effect of temperature is same. Effect of temperature is same. If the effect of pressure will follow Henry's law. What is Henry's law? It states that partial pressure of the gas in a vapor phase is proportional to the mole fraction of the gas. That is, we say P is directly proportional to what? Mole fraction of the gas. Say, for example, XA. If you remove the proportionality thing, it becomes KH into XA. And this Henry's law constant of solubility KH is inversely proportional to solubility. Then we know about Raoult's law. So Raoult's law says that PS is equal to P naught A plus P naught B plus P naught A into mole fraction of B. Where PS is equal to what? Total pressure, sir. What is P naught A? Vapor pressure of a pure state of a two constituent A and B. And we know that quality property means a property depends on number of solid particles. So which are the quality properties? Relative lowering of vapor pressure is a quality property. It is proportional to what? Mole fraction of A. What is mole fraction of A? Na by Na plus Nb. So what is Na? Na is number of moles of A. Number of moles of A. How to get it, sir? It is nothing but Wa by Ma, sir. What is Nb? So it's nothing but Wb by Nb. Wb by Mb, sir. Then the molecular weight of the solute. Molecular weight of solute can given by W into Mb by Wb into vapor pressure of a pure solvent. Next one. So elevation in boiling point. What is derivation in boiling point? So delta TB is equal to KB into M. What is M? Sir, M is the molality. Sir, M is the molality. Kb is the elevation constant or molar elevation constant, eboloscopic constant. So what is molality? Molality is equal to, sir, WA by MA into WB into 1000. So delta TB is equal to M. We can write it as KB into WA by MA into WB into 1000, sir. What is depression in freezing point? So DF is equal to KF into M. What is M? Again, M is molality, sir. So it becomes delta TF is equal to KF into W by MA into, this is WB into 1000. If you want to calculate KF and KB, KF and KB can also be calculated. MB RTF2 by 1000 delta enthalpy of fusion. What is MB there? R and MB stands for gas constant and molar mass of the solvent. And enthalpy fusion, enthalpy of vapors. These are for the solvent respectively. So what is atmospheric pressure? Pi is equal to CRT. C means what? Concentration. Or pi is equal to NBV, N by V RT. And we can also write it as pi is equal to WRT by MB because N is equal to weight by mass. So what is ideal solution? Which obeys Raoult's law at all temperature, all concentration. Where delta V is equal to 0, delta H is equal to 0. Because the AB attraction and A attraction and BB attractions are almost equal. Where it happens in case of dilute solution, ethyl bromide, ethyl iodide, bitter chloride, bitter bromide, where you will be having ideal solution. What is a positive deviation? Where the AB force of attraction is less. So delta V becomes more than 0, delta H is also more than 0. Example, acetone and ethanol, carbon tetrachloride and chloride. So what is negative deviation? Where AB force of attraction is more than AA and BB. So delta V becomes less than 0, delta H becomes less than 0. And acetone and then chloroform and ether are the examples. So what is a Vanta factor? Vanta factor is a correction what we add. Because whatever the molecular weight we calculate may not be the exact due to association or dissociation in the molecules. So to make correction, we add Vanta factor. What is I? Is a Vanta factor, sir. It's the molar ratio, a ratio of normal molar mass divided by observed molar mass. Or observed conductivity property divided by normal conductivity property. If I is equal to 1, then the solid remains unaffected. If I is more than 1, then the solid undergo dissociation. If I is less than 1, then the solid undergo association. Let's take a few questions on that part. Which of the following can be measured by the Ostwald-Walker dynamic method? This method we use it for what? for measuring relative lowering of vapor pressure. To measure the relative lowering of vapor pressure. So the option is sub B. Next, vapor pressure of a pure A is 70 mm of mercury at 25 degrees Celsius. It forms an ideal solution with B, in which mole fraction A is 0.8. If the vapor pressure of the solution is 84 mm of mercury at 25 degrees Celsius, vapor pressure of a pure B at 25 degrees Celsius is. So here there are two solids, A and B. That means Raoult's law. What is given? Let us see. So according to Raoult's law, we know that the total pressure P is equal to vapor pressure of a pure component A into mole fraction of A divided by vapor pressure of a pure component B into mole fraction of B. So the total pressure, what it is given, is 84 mm of mercury. So 84 is equal to P naught of A. How much it is? So 0.8. The mole fraction is 0.8. The vapor pressure of a pure A is what? 70. He says 70. So 70 into mole fraction. How much it is? 0.8. Plus, what we have to find out? The vapor pressure of a pure B at 25 degrees Celsius is. That means we don't know P not B. Not B. What is the mole fraction of B? Sir, we know that the total mole fraction of component Xa and Xb will be equal to 1. Then Xb is equal to how much? Already 1 minus 0.8 you are given. That means Xb should be 0.2 into 0.2. So it becomes P naught B is equal to, if you simplify it, it becomes how much? 28 by 0. That is 140, sir. 140 mm of mercury. 140 means what the option? So option is C. %6 solution of urea is isotonic with what, sir? What will be the option? He has given glucose. So he says osmotic pressure of glucose should be equal to what? Urea. Then concentration of glucose should be equal to concentration of urea. That means into 1000 divided by mg into 100 is equal to same way weight of urea into 1000 divided by mass of urea into 100. This is the mass of glucose. So if you substitute, so weight of glucose we don't know. Let us take it as x into 1000 divided by mass of glucose we know 180 into 100. Weight of urea we know 6 into 1000. Then what is the mass of urea, sir? 60 into 100. So how much x will be? How much it will be? So the 0 gets cancelled. Then so 6. Sir, x is equal to 18, sir. 18. He says percentage. That means 18 gram in 100 ml. 18 gram in 100 ml means that is almost 180 gram in 1000 ml. 180 gram in 1000 ml means it is 1 molar. That is glucose. Which one it is? Glucose. 1 molar. 1 molar means how, what is the option? So it is D, sir. D is the option. Next one. In a countries near to polar region, the roads are sprinkled with calcium chloride. This is to what? Why we do like this? Because calcium chloride is a non-volatile solute. Non-volatile solute. What it will do? It will do depression in freezing point. Depression in freezing point. And this will minimize the snowfall. That is option A. Next one. Just a minute, it is loading. Next one. The empirical formula of a non-electrolyte is CH2O. The solution containing 6 gram of compound exerts the same osmotic pressure as that of 0.05 molar glucose solution at the same temperature. The molecular formula of the compound is. What is the molecular formula of the compound? He says solution containing 6 gram of glucose. 6 gram of the compound exerts a same osmotic pressure as that of a glucose. What is the concentration of glucose? He has given 0.05 molar. That means then what is the mass of the glucose? Sir, mass of the glucose, W1, if you take glucose, he has given molarity. What is the molarity? 0.05. And we know molecular weight. What is the molecular weight? Sir, molecular weight is 180. So we get the concentration. How much it is? So around 9 gram we get it. Then W2 has given. W2 of the compound is how much? So the compound is 6 gram. He has given 6 grams. And he has not given anything about volume. That means we can take volume as equal. V1 is equal to V2 is equal to same. Let us take it as 1 liter. 1 liter. And when you say isotonic, already we have done once. Isotonic means what? W1 by M1 V1 is equal to W2 by M2 V2. This is the mass. And if we substitute here, what do we get? So 9 by 180 is equal to 6 by X. So what we get value is that X is equal to 120 grams. So how to find out empirical mass? N is equal to, sir, molecular mass by empirical mass. Molecular mass we got 120. What is empirical mass? Empirical formula, they are already given. CH2O. CH2O means carbon is 14, hydrogen is 2, oxygen is 16. So it becomes 30. So is equal to 4, sir. 4. So the molecular formula is nothing but, sir, N into CH2O. What is N into CH2O? That is, sir, N is how much we got? 4. So C4H8O, O4. So C4H8O4. That means option is D, sir. Option is D. Next one. A empirical formula of a non-electrolyte is CH2O. A solution contains 3 gram of a compound and exerts the same osmotic pressure as that of 0. The same way. Same way we have to do it. So what is the option? Option is B, sir. A solution of 2 liquid boils at a temperature more than the boiling point of either of them. Hence, the binary solution shows what? A solution of 2 liquid boils at a temperature more than the boiling point. When he says more than the boiling point, this is very important. More than the boiling point means vapor pressure of the solution is less. Of solution is less. That means, sir, it shows negative deviation. Negative deviation means what? Sir, option A. The mass of a non-volatile solute of molar mass 40 gram per mole that should be dissolved in 114 gram of octane to lower its vapor density by 20% is? What may be the option? What we have to calculate? We have to calculate mass of a non-volatile solute. By Raoult's law, we know that, sir, P naught minus P by P naught is equal to what? WA by MA mass and WA by MA plus WB by MB. Why you written like this, sir? So relative lowering of vapor pressure is proportional to what? Mole fraction. Mole fraction of what? So relative lowering of vapor pressure is proportional to mole fraction of XA. So that I have written like this. He says the mass of a non-volatile solute of molar mass 40 grams. Molar mass 14 grams, he says. He only has given mass. Molar mass is 40 grams. And that should be dissolved in 114 gram of octane. Octane means the molecular mass of octane that we have to take. There's 114 again. He says to lower its vapor density, vapor pressure by 20%. This is 20%. Then how much it will be? If you substitute this one, he says 20%. So 20% means 0.2. So WA by molar mass is 40. And WA by number of moles of Na means 40. Number of moles of octane. What is octane? Weight is 114. Molecular mass is 114. So how much we get? If you simplify this one, we get WA is equal to 10 grams. So 10 grams means it has to be options. Next one. So vapor pressure of two liquids A and B in their pure state are in the ratio 1:2, he says. 1:3. Vapor pressure two liquids, that is means A and B. He says ratio is 1:2 means 1/2. A binary solution of A and B contains A and B in the mole proportion of 1:2. The mole fraction of A in the vapor phase of the solution will be. What is the mole fraction of A? He says. What is the mole fraction of A? Mole fraction of A means what we write? We write it as Na by Na plus Nb, no? Plus Nb. So in this case, let us write it as Pa by Pa plus Pb. Pb. And from this equation, we can find out Pb. What is Pb? So Pb is equal to 2 into Pa. Let us substitute this one in equation 2. So what will happen? Sir, PA by PA plus 2PA. There is nothing but 1 by 3. 1 by 3. Because sir, PA gets cancelled. 1 by 3 means around 0.33, sir. That is option A. Which of the following is not a correlative property? So just lowering of vapor pressure is not a correlative property. It is a relative lowering of vapor pressure. That is called as correlative property. So D is the option. 3 grams of urea is dissolved in 45 grams of water. The relative lowering in vapor pressure is relative lowering in vapor pressure is. What may be the answer? What is relative lowering of vapor pressure? P naught minus P by P naught is equal to what? Mole fraction. Mole fraction. He has taken urea dissolved in 45 grams of water. So there's a urea and water is there. So let us take it as urea. So we can this write it as P naught minus P by P naught is equal to N of urea divided by number of moles of urea by plus number of moles of water. And this is dilute solution. For dilute solution, we can write it as P naught minus P by P naught is equal to number of moles of urea plus N2 by divided by N2. What is that N2? Water it is. Water. Why, sir? For dilute, concentration of urea can be neglected. Urea is neglected. Is neglected. So how much it is? Number of moles of urea means 3 by 60 and water is 45 grams by 80. So how much it is? So it is nothing but 0.02 mm. That means, sir, option C. Which of the following solution will exhibit highest boiling point? He says. Highest boiling point. Very simple. Who gives most highest I factor? That I factor is very important. We will give more ions or Na2SO4 will give more ions. Why? When dissociate, it gives 2 Na plus and 1 sulfate ion. So totally, the I factor is how much? It's 3, sir. 3. That means option C. So 5.5 milligram of nitrogen gas dissolves in 180 gram of water at 273 Kelvin and 1 atmosphere pressure due to nitrogen gas. The mole fraction of the nitrogen in 180 gram of water is at 5 atmosphere nitrogen pressure is approximately 6. First, we have to do it for 1 atmosphere. Sir, for 1 atmosphere, if we do it, so what is the number of moles? And always remember, number of moles of nitrogen, he says. How much he has given? Sir, 5.5 grams means we convert it into milligrams. Grams we convert 10 to the power of minus 3 divided by molecular mass, 28, sir. It is around 1.96 into 10 to the power of minus 4. This is at 1 atmosphere. Remember this. And he says at 5 atmosphere. And he says this is at 5 atmosphere. So what will happen at 5 atmosphere? It increases 5 times. That is 5 into 1.96. 1.96 means almost we can call it as 2. There is almost 10. So 10 into 10 to the power of minus 4. Or we can also write it as 1 into 10 to the power of minus 3. What the options are? Option C. What is the option? Sir, option C, sir. Next, we'll go to some questions in 2017 and 18. 2020. 17 we'll take. When the pure solvent diffuses out of the solution through semi-permeable membrane, then the process is called as what? I'll just take it. The process is called as what? We call it as a reverse osmosis. Vanta factor I accounts for what? Accounts for what? It indicates the extent of dissociation. The option B. Which of the following aqueous solution should have the highest boiling point? Highest boiling point. We know that delta TB is equal to what? So delta TB is equal to what? Kb into m. But I told you, we have to give a correction factor. What is the correction factor? I factor. Vanta factor, Kb into m. And in this, who is having highest I factor? The sodium sulfate. Last time we have done already. So sodium sulfate gives you 3 ions. So option should be B, sir. Isotonic solutions are having the same. What they'll be having? They'll be having the same osmotic pressure. Then, relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water. Already we have done many times. Sir, relative lowering of vapor pressure depends on what? Sir, depends on mole fraction, sir. He says mole fraction of what? Glucose. That is glucose, sir. So how much is given? Sir, 0.002 is equal to mole fraction means number of moles. Number of moles. Of what? Glucose by number of moles of glucose plus water. And this we can write it as 0.002 number of mass glucose by water. So because glucose in a dilute solution can be neglected. So this is nothing but number of moles of glucose is equal to 0.002 into number of moles of water. How much it is? 1000 by 80. So how much it will be? So 0.11. Yeah. That means, sir, option C. So the non-volatile solute A tetramerases in water. He says tetramerases in water. Means N factor is 4. To extent of 80%. To extent of 80%. That is alpha is equal to 80. .5 gram of A in 100 gram of water lowers the freezing point by 0.3 degrees Celsius. Hagadre molar mass of A in mole per liter is how much it is? So how to find out the I factor first here, sir? First we have to find out I factor. How to calculate this one? Alpha is equal to what? Sir, alpha is equal to 1 minus I factor into n by n minus 1. And he says alpha is 80%. That means 0.8 is equal to 1 minus I into n factor is what? 4, sir. 4 minus 3. That is. And if we simplify, I becomes 0.4. Then we have to find out what? The molar mass of A. Molar mass of A we have to find out. We know that delta TF is equal to what? Sir, I into KF into molality. I we know 0.4, sir. KF they have given 1.86. So what is molality? Mass by molar mass into 1000 kg by given mass 100, sir. Right. What is the mass? Sir, 2.5. What is the molar mass? That we have to find out, sir. That we have to find out. Because delta T of they are given 0.3. So that M we have to find out. That will be our answer. How much it will be, sir? 62. That is option A, sir. Next, we'll go to one more problem in 2019. Solution A contains acetone dissolved in chloroform. Remember this one. A contains acetone dissolved in chloroform. And solution B contains acetone dissolved in carbon disulfide. The type of deviation from Raoult's law shown by solution A and B. In case of acetone and chloroform, so in case of acetone and chloroform, so what will happen? The AB attraction is more than AA and BB. So delta V is less than 0. That means, sir, it's a negative deviation. The first one should be negative, sir. Then you have taken acetone and carbon disulfide, means CS2. CS2. Sir, AB attraction Here it is less. So it is delta V. AB attraction, sir. What will happen? Is less than AA and BB. So what will happen? The delta V becomes more than 0. So it becomes a positive deviation. So it's negative and positive. That is the option D, sir. So which of the following pair of solution is isotonic? Which of the following pair is isotonic, sir? What is isotonic? They should have a same osmotic pressure. Sir, same osmotic pressure they need to have. Let us start with one. We'll check all the things. What is osmotic pressure? Sir, pi is equal to, we know that one, CRT. But if you add correction factor, there's Vanta factor, I into CRT. Let us check for last one, which is the one, sir, barium chloride, BaCl2. BaCl2 gives you how many ions? Or 3 ions. So I is equal to 3. I is equal to 3. So pi is equal to ICRT means how much we get? So 3 into concentration is 0.01 and RT. That is, we can say 0.03 RT, sir. Let us take NaCl. Sir, NaCl gives you 2 ions. So I factor is equal to 2. Pi is equal to, sir, ICRT. What is the concentration? 2 into 0.015 into RT. That it becomes double. Double means exactly 0.03 RT. Yes, sir. In the case of NaCl and barium chloride, the pi value is same. The pi value becomes 6. That means option D, sir. So the solute X dimerizes water to the extent of 80%. This already I have done. One problem already we have calculated. 2.5 gram of X in 100 gram of water increases the boiling point by 0.3 degrees Celsius. So what is the molar mass of X is asking? So what we have to find out first? We have to find out I factor. He says dimerizes. So what we have to find? First we have to find out I factor. He says dimerizes. So in this case, I is equal to what? 1 plus alpha degree of dissociation by 1 minus n minus 1. He says dimerizes. Dimerizes means 1 plus alpha, 80% it is. Dimerizes means 1 by 2 minus 1. So here I value becomes 0.6. That we have to substitute where, so we know that delta TV is equal to what? I into Kb into M, molality. So what is molality? Molality is nothing but mass by molecular mass into kg, 1000 kg by given mass, 100 grams. I factor we got it, 0.6, sir. Kb is given 0.52. Mass is given 2.5 into 1000 divided by 100. So we don't know the mass, molecular mass we don't know. That we have to find out. Tb is given. How much it is? 0.3, sir. 0.3. So the mass we have to find out to be around 26, sir. That is option C, sir. So all this problem is almost similar. So what I'll do is that, okay, I will take the problem which are a bit different in that sense. Henry's law, constant for the solubility of N2 gas in water at 290 Kelvin is 1.0 into 10 to the power of 5 atmosphere. The mole fraction of nitrogen in air is 0.8. The number of moles of nitrogen from air dissolved in 10 moles of water at 290 Kelvin and 5 atmosphere pressure is, how much it will be? We have to find out number of moles of nitrogen. We have to find out. He has given the mole fraction. It is 0.8. Then what is the partial pressure? We know that partial pressure is nothing but of nitrogen is nothing but mole fraction of nitrogen into total pressure. The mole fraction of nitrogen is given 0.8 and the total pressure also is given 5. So it becomes around 4 atmosphere per atmosphere. Once we know that, then the partial pressure of nitrogen is equal to what? Kh into mole fraction of nitrogen. Kh also is given. How much it is? 10 to the power of 5. The partial pressure of nitrogen we got 4. So Kh is 10 to the power of 5. Then it is a mole fraction of nitrogen. What is mole fraction of nitrogen? Mole fraction of nitrogen is nothing but number of moles of nitrogen divided by number of moles of nitrogen plus water. So mole fraction of nitrogen is how much it is? So 4 into 10 to the power of minus 5, sir, is equal to number of moles of nitrogen divided by number of moles of nitrogen plus 10, sir. Because he has given 10 moles of water. 10 moles of water. So it becomes what? It becomes number of moles of nitrogen is equal to, sir, it becomes 4 into 10 to the power of minus 4. That is option is, sir, option is.
Service break time.
Okay, right, sir. Then please inform them tomorrow we will discuss P block and electrochemistry.
P block and
Electrochemistry.
okay. Dear students, now you will be having break 5:50 to 6:05. 6:05 you will be having biology class, Pawan sirs. PCM students who do not have biology can leave the class. And remaining students, please do join back at 6:05 without delay. Dear students, hope you're enjoying Daya, CET and NEET classes. Please put your feedback. In Q&A also you can put how is the feedback of the class. I would request you to join back exactly at 6:05 because we want you should not miss any important topic Each topic is important in competitive exam because what we predict, it may not happen in competitive exam. There is no fix from particular chapter, these many marks will come. In competitive exams, like theory and board exam, it is fixed that in any particular chapter you will be getting so much of marks. But every topic in competitive exam like CET and NEET is very important. Please be attending all the topics without delay. I request you to go for a break, get yourself refreshed, and join back sharp at 6:05 for the biology class of Professor Pawan Kumar. Thank you, students. Join back at 6:05.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Arohalli, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream.
One and do the yeah.
College is often viewed as a mere institution, a labyrinth of classrooms, textbooks, and endless exams, where our future is shaped. Yet, when we step foot on campus, we realize that we are not alone on this journey. University transcends academia, transforming into a vibrant community where individuals unite. To learn from one another, to grow and to forge unforgettable bonds. It's not always about having a precise plan. It's not always about figuring out. It's not always about reaching the finish line first. It's about discovering what we are truly passionate about. The true essence of college, however, lies beyond the confines of academic pursuits. What truly makes college so special is the life that's lived within its walls. It's about seeing things from different perspectives, exploring unique possibilities, taking on new challenges, finding joy in friendship, embracing individuality, expanding our knowledge and skills, and immersing ourselves in extraordinary experiences. It's a path that teaches us about resilience, courage, and determination. A quest that allows us to pursue our goals with purpose and clarity. A quest that helps us find balance, happiness, and fulfillment. A transformation that inspires us to live with intention, curiosity, and joy. A betrayal that leads us to a deeper understanding of who we are and what truly matters. It's a journey of self-discovery, where every experience shapes us into the best version of ourselves. What we live experiences shapes experience whole new world of academic excellence in a global environment. Future trailblazers today.
Nestled within the beautiful and peaceful setting of Dayanand Sagar University's Harohaldi campus is the prestigious College of Nursing, where you embark on a transformative journey as we flawlessly fuse academic expertise with practical skills through our advanced curriculum. Renowned for our focus on innovation and advancement, our experienced faculty members are at the forefront of the nursing field, constantly incorporating the latest advancements in technology and research into the curriculum. Pioneering facilities, including simulation labs and clinical training rooms, provide an immersive, real-world healthcare environment. The Harohaldi campus is a modern and supportive community, complete with all necessary amenities, and provides the perfect, serene environment for students to focus on their studies and achieve their goals. Join our vibrant community and prepare for a successful career in nursing. At Dayanand Sagar University's Harohaldi campus, the College of Physiotherapy is dedicated to providing students with a top-notch education in the field. Curriculum is designed to give students a comprehensive understanding of the human body and its functions, along with experiential training in the latest physiotherapy techniques. What sets our department apart is our ultra-modern facilities, including sophisticated classrooms and clinical training rooms. Our students have access to the latest technology and equipment, allowing them to hone their skills and knowledge to the highest degree. The faculty at the College of Physiotherapy is comprised of experienced professionals who are dedicated to their students' success. With our modern amenities, the supportive community, Dayanand Sagar University's College of Physiotherapy is the ideal place for aspiring physiotherapists to begin their journey.
Dear students, in another 2-3 minutes, your session will start. The biology session, as said, Professor Pawan Kumar is going to take a biology session. In the 2-3 minutes, and within that time, ask your friends all to log in back. As I said, it is very important. Each and every topic is important pertaining to CET NEET. We are going to have good topics of biology today now from Pawan sir. Hope all of you are enjoying the classes. Please do give a feedback in Q&A stating yes, no. How are you feeling about the class? Also, dear student, for the Dayanand Sagar admission test, I shared a link in chat box. Anyone who is interested to write the Dayanand Sagar admission test online home based on 24th May, please do register yourself by clicking the link which has been shared in the chat box. As I showed in the video, the campus is the same huge in 140 acres campus of Dayanand Sagar University, where we have BTech, we have medical, we have pharmacy, allied health science, physiotherapy, nursing. All these courses will be there in a one campus. It's a beautiful campus. Wish to write DSAT, can register yourself. Just another 2 minutes are there to start with biology class. I request you, please prepare properly for your exams. Because dear students, it's very important writing competitive exam, you know. Okay, competitive exam, the options look alike. Not many situation you will be undergoing. Like logical thinking you require. You need to manage the time. That the student who practice more will get all those skills. Till last minute, I request you to be practicing. I wish all of you should do good in all these exams. Keep practicing. That's what we are written in our Daya, you know, KCT program. That artwork we had written. Tomorrow belongs to those who prepare for today. Yes, dear students. Definitely tomorrow belongs to those who prepares for the today. Pawan sir, are you ready?
Yes, sir.
I'll hand over the session to you, Pawan sir. And today your topics are going to be, as mentioned here, class 11, part 1 revision. What are the topics, Pawan sir?
Sir, what I'm doing is I'm going to discuss the question paper from previous year so that all the chapters can be revised wherein then there is necessary. I mean, which are the chapters?
11th standard.
Yeah, 11th standard.
Okay. Dear students, in the question paper, the discussion, all 11th standard chapters should be revised. Definitely it is good. Almost 1 year back you have studied 11th standard or first PUC, which is getting revised. It is very good. Ask your all the friends to join back. Pawan sir, over to you. Session is over to you. And
Thank you, sir.
they'll put their questions in Q&A box, sir. You can check and answer them any queries, sir.
Sure, sure.
Thank you. Thank you.
So good evening, students. As I told, today's session, it will be on discussion of previous year questions. But it is not like normal questions discussion. We will not look into quick solutions. We will try to elaborate as much as possible from each of those questions so that we can cover most of the important concepts from that particular chapter. Sir, I cannot share my screen. It has been disabled.
I'll give you the power to share your screen, sir. Just 1 minute.
Yeah. So what I was telling was
you are able to share your screen. Please share the screen. I'll see and get back to you, sir. Thank you.
Yeah, I can share it, sir. Thank you. So as I was telling, the questions it will be discussed in little more detail, not just about looking into quick solutions for that. Number one. Number two is, I hope by now all of you are aware that questions from 11th standard for CET, it may be not having the same weightage as that of second PUC. Generally, we see that trend is that around 14 to 16 questions may arise from first PUC. So let us try to cover as many questions as possible so that we can have a large area of discussion throughout all the chapters. So I'm going to start with last year's CET question paper. So before I start with this 2022 question paper, let me remind you that the questions that were asked in 2022 were quite simple compared to that of other years. So let us start with these questions. So first question here is, which of the following hormone is not secreted by human placenta? Though it appears like question is from second PUC, that is from human reproduction, but it is somehow related to first PUC because there is a chapter called chemical coordination and integration. Which of the hormone is not secreted by human placenta? I can see a quick question as relaxin. See, as I told you, this is from previous year. I have not framed this question. But before you give the answer as relaxin, let me ask you this one. FSH, which hormone in human body is going to produce FSH? Yeah, answer you are telling it as A. Okay, let's come back to that answer. But which structure in human body produces FSH? Can I get a quick answer? Estrogen. No. Again, I'm repeating my question. Which structure or which gland in our body is responsible for production of an hormone called as FSH, of a hormone called as FSH? Very good. So it is pituitary gland. Now let us look into little more details about pituitary gland. You know, pituitary gland is a small structure which is present below the hypothalamus. And pituitary gland, it has got two parts in it. One is called as anterior pituitary lobe and the other one is called as posterior pituitary lobe. Now, this is present right below a structure called as hypothalamus. You know, hypothalamus is the part of brain. And in hypothalamus, you can see structures which are called as neurosecretory structures or neurosecretory cells, which are neurons, which produces hormones. So please remember, it is a neurosecretory structures, which means these are going to have neurons which produces hormones. And there are two type of neurons, if you can see here. One, the neuron which produces hormone and secretes that hormone through posterior pituitary gland. Whereas the other one, let me change the color for this. If you look at the yellow color neurons, which I'm going to draw now, these yellow color neurons are also neurosecretory cells, but they do not secrete it into any of the pituitary gland. But there is a structure which is a portal structure, which is in blood vessels, which carries the hormones from these yellow color cells into anterior pituitary lobe. Now, this yellow color structures, which are again neurosecretory cells, are going to produce two types of cells or two types of hormones. One is called as stimulatory hormones, and the other one, it is called as inhibitory hormones. Now, quick questions for you people. Can you name any one stimulatory hormone and any one inhibitory hormone produced by hypothalamus? Can I get a quick reply? Name any one stimulatory hormone first and then an inhibitory hormone next, which is produced by hypothalamus, not by pituitary gland, by hypothalamus. Okay. The stimulatory hormones which are produced are two at least. One is called as gonadotrophin release hormone, and the other one is called as thyroid stimulating hormone release hormone. I'm repeating, gonadotrophin release hormone, and the other one is thyroid stimulating hormone release hormone. These are the two stimulatory hormones which are produced by hypothalamus. Inhibitory hormone that is produced by hypothalamus is somatotrophin. So if this is a function of hypothalamus, the hormones which are produced by hypothalamus, somatostatin, sorry, not somatotrophin, somatostatin. These hormones are going to act on anterior pituitary lobe and produces these following hormones. Try to remember all these hormones. Hormones which are produced by this are as follows. To understand or to memorize these things easily, they often use this word called as flag top, where F stands for FSH, that is follicle stimulating hormone. L stands for luteinizing hormone, which acts on Leydig cells and stimulates androgen in case of male, and acts on ovary to induce ovulation on the 14th day of menstrual cycle in case of female. ACTH, adrenocorticotropic hormone, which acts on adrenaline gland to produce adrenaline gland hormones. GH, that is growth hormone, or you can also call it as GH, which is also called as somatotrophin hormone, and T, which stands for thyroid stimulating hormone, which acts on thyroid to produce thyroxine. O is just an empty letter which is used to form the word called as flag top. And P stands for prolactin, which is an hormone acts on mammary glands to produce milk. So the red color neurons that you're seeing here, they produce and secrete two types of hormones. Which are those? One is oxytocin and the other one is ADH, that is antidiuretic hormone, which is also called as vasopressin. So anterior pituitary lobe produces follicle stimulating hormone, luteinizing hormone, adenocorticotrophic hormone, growth hormone, thyroid stimulating hormone, and prolactin, and controls many other glands. And that's why the pituitary gland is called as master gland, or sometimes also referred as it's called as master gland. So yes, in your textbook, they have also given that relaxin is produced by ovary, but during pregnancy, it is also produced by placenta. So correct answer for this, it should be FSH, which is not at all produced by placenta at any cost. So answer is first one. See, I can see some of you are raising hands continuously. We are telling this repeatedly. Raising hands will not help you. If you have any doubts, please post it in question and answer box, Q&A box. Next question. Different types of respiratory organs like gills, book lungs, LUNGs, book lungs, and trachea are present in. So, this question is from a chapter called Animal Kingdom, which deals about different types of phylums. Out of that, the first phylum that you have studied is sponges. In case of sponges, there is no respiratory organs. There is no special respiratory organs, either respiration or excretion. It happens by simple diffusion. Sponges has a body structure like this, which will be having minute openings which are present on the body of sponges. They are called as ostia. If this is a structure of a sponge body, it will be having minute, it will be having minute opening which are called as ostia, and ostia helps in creating what is called as water canal system. Please understand, I'm talking about water canal system, not water circulatory system that you see in case of echinodermata, whereas this is called as water canal system. As the water passes through this, there will be both exchange of gases as well as there will be excretion of nitrogenous waste. So hence there is no respiratory organs or special respiratory structures are absent in case of sponges. In case of annelids, there is an excretory structure. There is an respiratory structures. In case of annelids also, there is no respiratory structures. One of the example of annelid is earthworm. And in case of earthworm, exchange of gases happens through the body surface. Exchange of gases happens through body surface. But for excretion, annelids have a structure which is called as nephridiophore. Nephridiophores are present in case of annelids, which is going to help in excretion. In case of molluscans, a structure called as gills, not book gills. There is no structure called as book gills. There is no structure called as book lungs. In case of molluscans, gills are going to help in both respiration as well as excretion. I'm repeating, in molluscans, gills helps in both respiration as well as excretion. Both takes place through the structures called as gills in case of molluscans. So whatever structure that you are seeing there in the names of names such as names such as book gills, book lungs, and trachea, they are all the structures which are present in arthropoda. And all of them are responsible for exchange of gases. All of them are responsible for exchange of gases. And arthropoda also have a structure called as Malpighian tubules. And it uses this Malpighian tubules for the purpose of excretion. This is used for excretion. So answer for this question should be fourth one. Good. I can see only one answering this, that is Susmita Rathod. See, I've told you in the previous session also, please make sure you actively participate in answering these questions. Otherwise, it will be not useful for you to increase your speed as well as accuracy. You have to try to give the answer, no matter whether it is right or wrong. Otherwise, your speed and accuracy is not going to increase in your exam. Fine. Next question. Which of the following plants is used to extract a chemical called as colchicine? Any answers? Don't say it is out of syllabus. All these were asked in the previous year NEET. Sorry, previous CET, that is just last year. Almost you can see the answer in the question itself. Any quick answers? Can you at the same time tell me to which family all this belongs to? Okay, this question is from a chapter called Morphology of Flowering Plants. This question is from Morphology of Flowering Plants. In Morphology of Flowering Plants, you have studied about 3 different phylums. Can you recall them? More phylum ನೀವು ಓದಿರೋದು ಯಾವ್ದ್ಯಾವ್ದರಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, first one is Fabaceae, second one is Solanaceae, and the third one is called as Liliaceae. So almost all these examples that you can see, it is coming from Liliaceae. If you can recall the economic importance of all this, if you recall the economic importance of all this, in that they are given that colchicum, it belongs to Liliaceae and it is going to be used for production of a chemical called as colchicine. And colchicine, it is used in case of production of hybrid plant to increase the number of chromosomes, or to induce polyploidy condition. They are going to use this colchicine chemical, and this is obtained from colchicum. And colchicum, it belongs to a family called as Liliaceae. So answer for this, it should be second one. You know what is the importance of tulip? Tulip is an ornamental plant and rest of them are for medicinal purpose. Next question. Row of S-shaped setae in the body of earthworm are present in all the segments except. First of all, I hope you remember what is the function of setae. Setae is a locomotory structure. It's a locomotory structure which is present in case of earthworm. And earthworm belongs to an phylum called as Annelida. In Annelida, you may remember one more locomotory structure which is called as parapodium. Parapodium is a locomotory structure in an aquatic annelid called as Nereis. Which means you can consider this from 2 chapters. One from structural organization in animals, and the other one is from animal kingdom. So in animal kingdom, I just like to quickly look into what are the locomotory structures that you see. In case of Annelida, the locomotory structure is, in case of Annelida, as I just now told, earthworm, which belongs to Annelida as in setae, whereas aquatic Annelida such as Nereis as in locomotive structures such as parapodium, parapodium. And one more important locomotive structure that you see is tube feet. Can anyone tell me where do you find this tube feet? In which phylum do you find tube feet? These are the three locomotive structures which has been especially discussed in animal kingdom. So I just wanted to mention all these three: setae, parapodia, and tube feet. Can you tell me where do you find tube feet? Which phylum has an locomotive structure called as tube feet? Any answers? As an int, I can say, very good, very good. I don't know who is this actual name, but anonymous attendee, you are absolutely right. Echinodermata has this locomotive structures called as tube feet. And echinodermata also have one more particular character, which is called as water vascular system. So I told you in the beginning of this chapter that this is about the revision of entire 11th or first PUC chapters. So don't just look into only one or two solutions from the chapter, from each question. Try to cover as much as possible. That's what I'm trying to do. And while doing this, if you get any doubts from any of this concept, please feel free to ask me those doubts. So what I'm telling is 4 points. One is setae and locomotive structures, which is present in earthworm, which belongs to Annelida. Parapodium is also a locomotive structure, which is also present in Annelida, but it is present in Nereis, which is an aquatic Annelida. In case of echinodermata, they have got a locomotive structure in the form of tube feet. And one more particular or special character of echinodermata is having a water vascular system. They do not have blood. Instead of that, the water runs through their body. Yeah. So answer for this question then over here. The question is about are present in all the segment except. ಅದರರ್ಥ ಯಾವುದೋ ಒಂದು ಸೆಗ್ಮೆಂಟ್ ಅಲ್ಲಿ ಬಿಟ್ಟು ಬೇರೆ ಎಲ್ಲಾ ಕಡೆ ಇರುತ್ತೆ ಅಥವಾ ಒಂದು ಕಡೆ ಬಿಟ್ಟು ಬೇರೆ ಎಲ್ಲಾ ಕಡೆ ಇರುತ್ತೆ, ಯಾವ ಕಡೆ ಇರಲ್ಲ ಅಂತ ಪ್ರಶ್ನೆ. It is not present in first segment. It is not present in last segment also. At the same time, scutellum, which is an glandular structures which is present in segment number 14 to 16. Scutellum is a structure which is present from segment number 14 to 16. Even in scutellum also it is absent. So the answer should be fourth one. That is, it is absent in first segment, last segment, as well as scutellum. Next, cell theory was formulated by, cell theory was put forward by two European scientists, out of which one was Sklenden and the other one was Squan. Sklenden was from Germany. He was from Germany, and Squan, he was from England. He was from England, whereas Sklenden was from Germany. Sklenden was basically botanist, and Squan was basically zoologist. So both of them observed that all living organisms are made up of structural and functional units, which are called as cells. And they also observed that all plants have a boundary in the form of cell wall. And these two put forward the cell theory, which states that all living organisms are made up of structural and functional units called as cells. Can you remember one more person who was a Russian scientist who added one more point? Cell theory has two components in it. ಎರಡು ಭಾಗ ಇದೆ cell theory ನಲ್ಲಿ. One, it says that all living organisms are made of structural and functional units which are called as cells. This is one component of cell theory. There was one more scientist who added to this. What was added was that all cells arise from pre-existing cell, which means cells cannot be created. Cells galna ಸೃಷ್ಟಿ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಈಗಾಗಲೇ ಯಾವ್ದಾದ್ರು ಸೆಲ್ಸ್ ಗಳಿದ್ರೆ ಆ ಸೆಲ್ಸ್ ಗಳಿಂದ ಹೊಸ ಸೆಲ್ಸ್ ಗಳು ಬರ್ಬೋದೇ ಹೊರತು you cannot create a cell, but cells arise from pre-existing cell. I'm still waiting for your answer. Who proposed this? ಎರಡನೇ ಪಾಯಿಂಟ್ ಅನ್ನ ಪ್ರಪೋಸ್ ಮಾಡಿದವ್ರು ಯಾರು? ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಅಂತೂ ಇವರಿಬ್ರು. ಎರಡನೇ ಪಾಯಿಂಟ್ I will be waiting for your answer. ಆನ್ಸರ್ಗೋಸ್ಕರ ಕಾಯ್ತಾ ಇರ್ತೀನಿ. Very good. And Russian scientist called as Rudolf Virchow. I hope you remember his sentence. Ominia e cellulea. Ominia e cellulea means the cells arise from pre-existing cells. So these two together is what is called as the cell theory. And other names here, ಬೇರೆ ಹೆಸರು ಯಾವ್ದ್ಯಾವ್ದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, it includes Robert Brown. I hope you remember the contribution of Robert Brown. He was the person who discovered nucleus. Cell ಒಳಗಡೆ ಇರೋ ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನ ಫಸ್ಟ್ ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ದು ರಾಬರ್ಟ್ ಬ್ರೌನ್. You know, nucleus is a double membrane structure. ಅದರಲ್ಲಿ ಎರಡು ಪಾರ್ಟ್ ಇರುತ್ತೆ, ಔಟರ್ membrane and inner membrane. And you can see in many places there will be small pores which are called as nuclear pores. And inside this nucleus you can see a chromatin network, which will be in the form of thin thread-like structures. And in some places you can find darkly stained structures which are called as nucleolus. ಕೆಲವೊಂದು ಕಡೆ ಡಾರ್ಕ್ ಆಗಿ ಸ್ಟೈನ್ ಆಗಿರೋ ಸ್ಟ್ರಕ್ಚರ್ ಇರುತ್ತೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ. That is called as nucleolus. Nucleolus is the site for synthesis of rRNA, which is the component of ribosome. Ribosome ina bhaga agiro rRNA ಅನ್ನು synthesize ಮಾಡೋದು nucleolus ಇರೋ ಜಾಗದಲ್ಲಿ. Rest of this part, it is called as nucleoplasm. So this particular structure, nucleus, was discovered by Robert Brown. And I hope you remember the contribution of Robert Hooke. He was the first person to see the dead cells from cork. He was the first person to observe those cells under microscope. However, the answer for this question, it should be second one. Next question. This question is from the chapter Biomolecules. The type of polysaccharide present in cotton fiber is what? Cellulose. Very good. Where do you find glycogen? Glycogen is a storage polysaccharide. It's a storage polysaccharide in animals. Animals ಗಳಲ್ಲಿ extra carbohydrate anna it is going to store it in the form of glycogen. Starch is also a storage polysaccharide, but it is found only in case of plants. Insulin is not a carbohydrate, rather it is a protein which is going to act as hormone. And I also hope you remember there is a carbohydrate called as inulin, which is a polysaccharide made up of fructose. Cellulose is a structural polysaccharide. It's a structural polysaccharide which is present in case of plant's cell wall, as well as plant cell wall. Sorry, I'm very sorry. It is present in the form of, yeah, correct. It is present in the plant's cell wall, Also, it is present in the cotton fiber. Now, all this, in fact, glycogen, starch, and cell wall of plants, which is made up of cellulose, all this, not this one. All these are made up of same repetitive unit, which is called as glucose, wherein glycogen will be having a branched polysaccharide like this, which is made up of glucose. I hope you remember. ಈ ತರ ಬ್ರಾಂಚ್ ಆಗಿರೋ ಗ್ಲೂಕೋಸ್ ಚೈನ್ ಅನ್ನ, branch of glucose chain like this. These branches of glucose is called as amylopectin, which is present in case of glycogen. Whereas starch has this amylopectin plus it will be having amylose. And amylose are coiled structure like this. Whereas cellulose, on the other hand, it will be made up of, again, glucose, which are joined by beta 1,4-glycosidic bond, and it appears straight. And all of them are also examples of what is called as homopolysaccharide. All these are the examples of homopolysaccharide. So the answer for this, it should be cellulose, fourth one. Good. Next question. I can see answer as A by somebody, humans by somebody, Karthik. Oh yeah, Karthik, if you are telling that that is about glycogen storage, yes, not only in humans, but it is also found in all animals also. Enzymes which are involved in crossing over. So where does this chapter, or from which concept does this comes from? This is from a chapter called Cell Cycle and Cell Division. With respect to cell cycle, in this chapter, you have studied that cell cycle, it will be having G1 phase, S phase, G2 phase, and M phase. Where in G1 phase, there will be protein synthesis and the cell grows. And in S phase, which is also called as synthesis phase, there will be replication of DNA. There will be replication of DNA. Please understand what I am telling carefully now. At the end of S phase, the number of chromosome remains same, but the amount of DNA gets doubled. ಅದರ ಅರ್ಥ G1 phase ನಲ್ಲಿ number of chromosomes, if the number of chromosome is deployed and concentration of DNA, let us say it is 2C, by the end of S phase, number of chromosomes remains deployed, but the concentration of DNA increases to 4C, because S phase is about replication, and you know in replication there will be synthesis of DNA, and hence the amount of DNA doubles, but the number of chromosomes are missing. In G2 phase, it is going to synthesize all the proteins and RNA required for M phase. And M phase, which is mitotic phase, which will be having prophase, metaphase, anaphase, and telophase. But this concept of crossing over do not comes in mitosis, but it comes in one more kind of cell division, which is called as meiosis. I hope you remember meiosis as meiosis 1 and meiosis 2. Meiosis 1 is again subdivided into following phases, which are those. One is called as prophase 1, metaphase 1, anaphase 1, and telophase 1. Prophase 1 is the longest one and very important phase of this cell division. And what happens during prophase 1 is it is further divided into many 5 different phases. Adanna ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿಕ್ಕೆ they use this sentence called like lazy zebras pack dry diapers, wherein this L stands for leptotene, Z stands for zygotine, P stands for pacetine, D stands for diplotene, and Daya of diaper stands for diakinesis. So these are the different phases that you see during prophase 1. And you know what happens in each one of them? Let me quickly tell you what happens in each of these stages. In case of leptotene, what happens is chromosomes are going to start to condense. They'll start to condense. In zygotine, they are going to start forming a pairs, and that is called as formation of synapses. And in pacetine, maternal and paternal chromosomes undergoes crossing over. This process of crossing over is also called as recombination. This process is also called as recombination, where both paternal and maternal chromosomes of homologous chromosomes, not heterologous, homologous chromosomes between non-sister chromatids. I'm repeating, between non-sister chromatid. If this is one chromosome and if these are the sister chromatids of this chromosome, let us assume this is paternal one, ತಂದೆಯಿಂದ ಬಂದಿರೋ ಅಥವಾ male parent ಇಂದ ಬಂದಿರೋ chromosome. And the one more which I am writing here, it is an maternal, that is coming from female. They both exchange their chromosome. These two are considered as these two are considered as non-sister chromatids, and crossing over happens between non-sister chromatids. So since it's a process of recombination, there is an enzyme called as recombinase. There is an enzyme called as recombinase, which is responsible for recombination, which is present as a part of synaptonemal complex. I'm repeating, it is present as a part of synaptonemal complex. And during diplotene, what happens is there is formation of chiasmata, and in diakinesis there will be terminalization. So this is about prophase 1. You know, in metaphase 1, homologous chromosomes will align in front of each other. Whereas in case of anaphase, the spindle fibers are going to separate them, and thereby the number of chromosomes will be reduced to half. Please observe this. As I told you again, the intention is not to look at quickly the answers, but to look at the overall concepts. So if you look at homologous chromosomes, let us say this is a pair of maternal chromosomes. This is one, and this is another. Male parent in a chromosome anta ankoಣ. Let us consider this yellow color chromosomes as the chromosomes from female parent. Now, each of these homologous chromosomes will align opposite to each other during meiosis. This is how meiosis once metaphase 1 appears. But if you look at the chromosomes alignment in metaphase of mitosis innali chromosomes alignment anna nodidre, it appears like this. All the chromosomes, either homologous or not homologous, either heterologous or homologous, all chromosomes will be aligned in a same equator plane like this. Ella ondru pakka ondirutte. This is how chromosomes will align in the metaphase of mitosis. Idu mitosis nalli ಕಂಡು ಬಂದ್ರೆ ಒಂದಕ್ಕೊಂದು ಆಪೋಸಿಟ್ ಆಗಿ ಕಂಡು ಬರೋದು, the one which is going to appear as if they'll align one in front of each other, it appears during meiosis 1, that is metaphase 1. Whereas in case of metaphase of mitosis, ನಾನು ಇದನ್ನ ಸ್ಟ್ರೆಸ್ ಮಾಡಿ ಏನು ಕೇಳ್ತಾ ಇರೋದು ಅಂತ ಹೇಳಿದ್ರೆ, in your exam they may ask question like, they may give a diagram of an cell which is in metaphase 1 of meiosis, and also a diagram of a cell which is present in metaphase of mitosis, and they may ask you to identify which stage is this. Idu meiosis da metaphase da anta prashne keltare. Second thing that you should observe here in this diagram is, after metaphase 1 ಆದ್ಮೇಲೆ next ನಡೆಯೋದು, it is called as, the next phase after this, it will be anaphase. Now look at the anaphase 1 and anaphase of mitosis. ಈಗ chromosomes ಗಳಿದನ್ನು ಹಿಡ್ಕೊಂಡು ಎಳೆಯುತ್ತೆ. Chromosomes will be pulled apart from each other with the help of spindle fibers. But the structure here, which is called as centromere ಏನಿದೆಯೋ ಅದು ಡಿವೈಡ್ ಆಗಲ್ಲ. Centromere do not split during anaphase 1. Whereas the same centromere, it has been attached to the same opposite spindle fibers, and hence the centromeres are going to split in anaphase of mitosis. And in fact, centromere is also going to split in anaphase 2 of meiosis, but centromeres are not going to split. I'm repeating, centromeres are not going to split during anaphase 1 of meiosis because chromosomes are aligned opposite to each other. So I hope you got the answer for this question. The enzymes involved in the process of crossing over is an enzyme called as recombinase. I'm sure you know other enzymes also. You know, ligase is meant for joining molecules. If it is DNA ligase, it is going to join two DNA ligase, two strands of DNA. Polymerase, it's an enzyme, as the name itself indicates, it polymerizes the monomers. If it is DNA polymerase, it polymerizes DNA nucleotides. If it is RNA polymerase, it polymerizes RNA nucleotides. And you know, endonuclease are the structures which is going to break or cut the DNA. Okay, so answer for this, it should be second one. Next question. Cran's anatomy can be seen in maize, tomato, potato, and pea. Answer. I can see only one answer, that is in P. P is not correct answer. Okay, I'll start giving you the int. Let me see at which int you're going to give me this answer. Int number 1. This is from a chapter called photosynthesis in higher plants. B. B is not correct answer. Second one. This is meant for preventing a phenomenon called as photorespiration. Photorespiration anna tadilikoskara evolve agiro special type of plants ಗಳಲ್ಲಿ Cran's anatomy ಕಾಣಿಸುತ್ತೆ. Cran's anatomy is seen in those plants which are meant for preventing photorespiration. Third and last hint, Cran's anatomy is found in case of C4 plants. C4 plants can prevent photorespiration because it will be having Cran's anatomy. Okay, I can see the answers P, D, 1B, B, tomato, no. None of them. Only one correct answer is there, that is from Sandhya V. So the correct answer for this, it should be maize. Maize and sorghum. Maize and sorghum are the two plants which have been given as example for C4 plants in your book. And Cran's anatomy is something which is meant for preventing photorespiration by C4 plants. Now, what happens in Cran's anatomy is, if you consider this as a cross-section of a leaf, if you consider this as a cross-section of leaf, you know, it will be having two types of cells. One green color cells which are present here, which are called as mesophyll cells. And the other group of cells which will be present around the vascular bundles, which are called as xylem and phloem. Xylem ಮತ್ತೆ phloem ಸುತ್ತ ಇರೋದನ್ನ vascular bundles sheath ಅಂತ ಕರೀತಾರೆ. In other, to put it in simple words, these are called as bundle sheath cells, which will be of many layers, and it will be having a very thick cell wall which will be impermeable to gases. It will be having a thick cell wall which will be impermeable to gases, and it looks like an wreath. ಡೆಡ್ ಬಾಡಿ ಮೇಲೆ ಇಡ್ತಾರಲ್ಲ, ಗ್ರೀನ್ ಕಲರ್ ಇರುತ್ತೆ ಶವಪೆಟ್ಟಿಗೆ ಮೇಲೆ ಇಡೋದು, ಆ ತರ ರೆತ್ ಕಾಣಿಸ್ದಂಗೆ ಕಾಣಿಸುತ್ತೆ. This is what we call it as Cran's anatomy. So what is the speciality about this anatomy is, as I'm telling, it has got two types of leaves. One is mesophyll leaves and the other one is bundle sheath leaves. So to prevent photorespiration, what happens inside? What happens inside mesophyll cells is carbon dioxide, which reacts with water, will be converted into carbonic acid, that is H2CO3 minus, which reacts with a 3-carbon molecule. I'm repeating, 3-carbon molecule called as phosphoenol pyruvate, and it will be converted into 4-carbon molecule. You know, 1 carbon is present in carbon dioxide. Phosphoenol pyruvate has 3 carbons in it. Together it is going to form first stable compound, which will be having 4 carbon in it, which is called as oxaloacetic acid. First stable compound ನಲ್ಲಿ 4 ಕಾರ್ಬನ್ ಇರೋದ್ರಿಂದ ಈ ತರದ ಪ್ಲಾಂಟ್ಸ್ ಗಳನ್ನ C4 plants ಅಂತ ಕರೀತಾರೆ. And this cycle is called as C4 cycle. This oxaloacetic acid is then transported into bundle sheath cells. In bundle sheath cells, it may be converted into malic acid. Will be converted into malic acid, which also has 4 carbon in it, out of which 1 carbon comes out in the form of carbon dioxide. 1 carbon comes out in the form of carbon dioxide, and thereby converting malic acid into pyruvic acid, and pyruvic acid, it will be converted back into phosphoenol pyruvate. ಇಲ್ಲಿ ರಿಲೀಸ್ ಆಗಿರೋ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅನ್ನ ತಗೊಂಡು ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಅಂಡರ್ಗೋ ವಾಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕೆಲ್ವಿನ್ ಸೈಕಲ್ ಅನ್ನ ನಡೆಯುತ್ತೆ. ಸೊ ಈ ತರ ಫೋಟೋಸಿಂಥಸಿಸ್ ಅನ್ನ ಇಂಪ್ರೂವ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ C4 ಪ್ಲಾಂಟ್ಸ್ ನಲ್ಲಿ, ಮತ್ತೆ ಜ್ಞಾಪಿಸ್ತಾ ಇದ್ದೀನಿ ನಿಮ್ಗೆ, ದ ರೀಸನ್ ಫಾರ್ ಆಲ್ ದಿಸ್ ಸರ್ಕಸ್ ಆರ್ ರೀಸನ್ ಫಾರ್ ಆಲ್ ದಿಸ್ changes is because to prevent is to prevent photorespiration, because photorespiration is waste of energy. ಇದು photorespiration ಎನರ್ಜಿನ ವೇಸ್ಟ್ ಮಾಡಿ ಫೋಟೋಸಿಂಥಸಿಸ್ ಅನ್ನ ಕಡಿಮೆ ಮಾಡುತ್ತೆ. ಆ ತರದ್ದನ್ನ ತಡಿಲಿಕ್ಕೆ, to prevent that photorespiration, they will be having what is called as Krantz anatomy in C4 plants, which is seen in case of maize and sorghum, and hence the answer should be first one. I hope those who gave other answers, you understood this. Ondsari reply ಮಾಡ್ತೀರಾ ಇದು ಅರ್ಥ ಆಯ್ತಾ ಅಂತ? Those who especially gave the answer as pea and tomato, I hope you people are not confused. The answer should be wheat. Okay. Next question answer it. Respiratory coefficient of glucose is quite very simple question. You know what do you mean by respiratory coefficient? It is respiratory coefficient is given by the number of carbon dioxide released, divided by number of oxygen consumed. So, you know, according to the respiration chemical formula, we have seen that during respiration, C6H12O6 glucose, it is going to get oxidized by carbon dioxide to produce, oxidized by oxygen to produce carbon dioxide plus water plus energy, out of which 6 carbon dioxide is released and 6 carbon dioxide is consumed, which means number of carbon dioxide released is 6 divided by number of oxygen consumed is 6, 1. So for all carbohydrates, it may be for glucose, fructose, maltose, sucrose, for all carbohydrates, the respiratory coefficient, it will be 1. I want quick answers. Try ಮಾಡ್ಲೇಬೇಕು ನಾನು ಕೇಳ್ತಾ ಇರೋ ಪ್ರಶ್ನೆಗೆ ಉತ್ತರನ. Respiratory coefficient 0.7 ಯಾವುದಕ್ಕಿರುತ್ತೆ, 0.9 ಯಾವುದಕ್ಕಿರುತ್ತೆ? Which molecule will be having a respiratory coefficient of 0.7, and which one will be having respiratory coefficient of 0.9? All these are there in your syllabus. You have studied that. So this is why I'm telling you have to think broadly when we are doing these sessions, not just 1 or 2 options. Still waiting. 0.7 yaudrudu respiratory coefficient. Very good. 0.7, it is of tripalmitic acid, which is a fatty acid. There is a fatty acid called as tripalmitin acid. The respiratory coefficient of that, it will be 0.7. Which molecule will show the respiratory coefficient of 0.9? Any answers? Very good. So respiratory coefficient of proteins will be 0.9. More than 1. Which molecule will be having respiratory coefficient of more than 1 is if the respiratory substrate is organic acid. Respiratory substrate another organic acid agidre, avaga it will be more than 1. During fermentation, the respiratory coefficient, it will be infinite. During fermentation, respiratory coefficient, it will be infinite, because during fermentation only carbon dioxide is released, but glucose is not consumed. So any number divided by 0, it will be infinite. So for all carbohydrate 1, fatty acid 0.7, particularly tripalmitic acid, protein 0.9, organic acids more than 1, and for fermentation it will be infinite. The answer for this question should be first one. Yeah. A person suddenly starts coughing while swallowing food. This coughing would have been due to improper movement of. ಟಂಗಿನ ಇಂಪ್ರಾಪರ್ ಮೂವ್ಮೆಂಟ್ ಆದ್ರೆ ಕೆಮ್ಮು ಬರಲ್ಲ. ನೆಕ್ಕಿಗೂ ಡೈಜೆಸ್ಟಿವ್ ಸಿಸ್ಟಮಿಗೂ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯಾವುದೇ ತರದ ರಿಲೇಶನ್ಶಿಪ್ ಇರಲ್ಲ. ಹಾಗಾದ್ರೆ ಆನ್ಸರ್ ಏನಾಗ್ಬೋದು? Can you give me the answer? Very good. So answer should be epiglottis. I hope most of you know what do you mean by epiglottis. If this is trachea, white color bardirodu trachea, and it branches to form the structure called as bronchioles, which enters into lungs. It becomes a part of lungs. I'm sorry. Okay, anyway, let us not give too much of importance for diagram. Right next to this, adar pakkadale innond tube irutte. The tube is called as esophagus. Now, esophagus is also called as food pipe, whereas trachea is called as windpipe. So at the opening of this trachea, or in the junction where this trachea and esophagus meets, meet agato, there is a flap-like structures which are called as epiglottis. Flap-like structures which are called as epiglottis, which will be immediately closing this trachea when the food is being swallowed. Suppose if this do not functions properly, there is a possibility that some amount of food may enter into trachea, and to remove that, there will be coughing. So person suddenly starts coughing while swallowing the food. This is because of improper movement of epiglottis. You know, diaphragm is a muscle which is present below the lungs, which is meant for both inspiration as well as expiration. If diaphragm becomes dome-shaped and diaphragms becomes flat. Now answer this question. Dome shape ಆದಾಗ ಏನಾಗುತ್ತೆ? ಇನ್ಸ್ಪಿರೇಷನ್ ನ ಎಕ್ಸ್ಪಿರೇಷನ್. ಡೂಮ್ ಶೇಪ್ ಆದಾಗ ಏನಾಗುತ್ತೆ? ಇನ್ಸ್ಪಿರೇಷನ್ ನ ಎಕ್ಸ್ಪಿರೇಷನ್. ಫ್ಲಾಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ? ಇನ್ಸ್ಪಿರೇಷನ್ ನ expiration. When the diaphragm becomes flat, I'll give it as A and B. Punit Chavan, this is not particular chapter, so there is no notes. If you want me to send the slide, I can send you the slide. But there is no notes for this session because this is previous year questions that has been discussed. Yeah, ಹೇಳ್ತೀರಾ ಈಗ ಬೇಗ A ಏನಾಗುತ್ತೆ, B ಏನಾಗುತ್ತೆ? See, there are around 20, more than 25 participants right now, and now it is becoming 30. I can see very few people who are responding. A ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, B ನಲ್ಲಿ ಏನಾಗುತ್ತೆ. A ನಲ್ಲಿ ಆಗೋದು it is called as inspiration. B ನಲ್ಲಿ ಆಗೋದು, sorry, I'm very sorry. A ನಲ್ಲಿ ಆಗೋದು it is expiration. B ನಲ್ಲಿ ಆಗೋದು inspiration. A ನಲ್ಲಿ pressure, it is going to decrease. Pressure decreases, sorry, pressure increases. Since the pressure increases, it goes out. Gas goes out. Expiration. B ನಲ್ಲಿ pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Pressure is going to decrease. Pressure is going to decrease because volume is going to increase. So this way, it is going to control inspiration and expiration. Correct, Aditya KG. So diaphragm is meant for inspiration and expiration. Next question. Direct fact-based question. Quick answer. We'll go to the next question. Binomial nomenclature was introduced by John Ray, was the person who coined the term species. Species ಅನ್ನೋ ಪದನ, species term was coined by John Ray. You know, Carolus Linnaeus wrote a book called as Genera, sorry, what was the book written by Carolus Linnaeus? Can you just tell me? I'm just finding it difficult to recall that. What was the book written by Carolus Linnaeus? Name of the book written by Carolus Linnaeus. I can see one of you are giving the answer as third one. No. Lamarck was the person who tried to explain evolution. Lamarck tried to explain the concept of evolution, not anything about nomenclature. He was the person who gave use and disuse theory. Yeah, Species Plantarum was the book which was written by Carolus Linnaeus, and he was the first person to use binomial nomenclature. Bentham and Hooker, I hope you remember, they were the first people to introduce natural system of classification. Natural system of classification was first time introduced by Bentham and Hooker. You know difference between natural system and the other one is artificial system of classification. Artificial system of classification is based on artificial system of classification. It will be based on very few characters, observable characters, whereas natural system, it will be involving many characters. ಎಷ್ಟೊಂದು ಕ್ಯಾರೆಕ್ಟರ್ಸ್ಗಳನ್ನ ತಗೊಂಡು ಕ್ಲಾಸಿಫೈ ಮಾಡಿದ್ರೆ ನ್ಯಾಚುರಲ್ ಸಿಸ್ಟಮ್, ಕೆಲವೇ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ಗಳನ್ನ ತಗೊಂಡು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡಿದ್ರೆ ಆರ್ಟಿಫಿಷಿಯಲ್. Bentham and Hooker were the first people to introduce natural system of classification while classifying the plants. So you know what are the rules that are used in binomial nomenclature. It should be having two names. The first name, it will be of genus. Second name, it will be of species. And first name should be of capital letter and second name, it should be of small letter. The word should be derived from Latin. If it is not there in Latin, it should be Latinized. If you are typing it, it should be in the italic font. If it is being written, it should be underlined. So these are introduced by Carolus Linnaeus. Yeah, next question. Bovine spongiform encephalopathy, which is also called as mad cow disease, is caused by what? This question is from a chapter called biological classification. Under the last part of biological classification, you have studied about virus, viroids, and prions. And in fact, one more thing that you have studied is lichens. So bovine spongiform encephalopathy, it is caused by what? Yeah, it is caused by 332. Okay. Two viroids causes a disease called as potato tuber spindle disease. Viroids causes potato tuber spindle disease, not mad cow disease. Mad cow disease is caused by prions. Something similar to mad cow disease is also found in humans, which are called as C.R. Jacobs. C.R. Jacobs disease is also caused by prions, but this disease is caused in case of humans, whereas bovine spongiform encephalopathy, it is caused in case of cow. Answer should be prions. Yeah, next question. Phycoerythrin and Floridian starch is found in phycoerythrin, erythro, which means red color. Phyco means algae. Algae which are having red color pigment, they are called as red algae. And they are also called as rhodophyceae. Blue-green algae, it will be having chlorophyll A. Green algae will be having chlorophyll A and it will be also having chlorophyll B. Red algae, it will be having chlorophyll A and chlorophyll D. Brown algae, it will be having chlorophyll A and chlorophyll C. Along with chlorophyll A and D, just 1 minute. Yeah, I'm sorry. Along with chlorophyll A and D in case of red algae, it will be having phycoerythrin. Along with chlorophyll A and B, sorry, there is only chlorophyll A and B in green algae. In case of brown algae, along with A and C, it will be also having xanthophylls. Please remember these pigments, it will be important. Floridian starch, which is also considered in the other names as amylopectin. Floridian starch or amylopectin is a reserved food material which is present in case of red algae. I'll just put it in different colors so that you will understand whatever I'm writing now. It is of reserved food material. It is Floridian starch, which is present in case of red algae. Whereas in case of green algae, what you find is starch. And also you can find some of the lipids. And you may remember you have studied about something called as pyrenoids, which are the mixture of starch and proteins. All these are present in case of green algae. Brown algae, it will be having laminarin and mannitol. Laminarin and mannitol are the reserved food material that you find in brown algae. So I suggest you in the chapter called Plant Kingdom, there is a table which summarizes what are the properties of red algae, green algae, and brown algae. I strongly suggest to go through that and try to memorize all those properties of red, brown, and green algae. However, the correct answer here is it should be having phycoerythrin along with chlorophyll A and B, and it will be having reserved food material in the form of Floridian starch, which is nothing but amylopectin. So it should be first one. Next question. Again, very, very simple. I'm expecting that most of you will give the answer. Stalk of the stamen is called as I hope you remember stamens are the units of androecium. Stamens are the units of androecium. It will be having a stalk and it will be having an anther like this. This is called as anther. And what do you call the base as? What do you call this as? As I told you, very, very simple question. I can see only 3 of you are answering. I don't know if you people are taking it seriously. If you do not try to answer your questions in your exam, it is going to be very, very difficult to increase the speed. Yeah, so at least out of 4 of you who have given the answer, 5 of you, the answer should be filament. Both anther and filament together is called as stamen. And stamens are the units of androecium. Stamens are the units of androecium. Peduncle is a stalk of the flower. Pedicel, peduncle is a stalk of the inflorescence. Pedicel is a stalk of the flower. And petiole is stalk of the leaf. The answer should be second one. Next. The most abundant type of WBCs. You know, blood has 2 components. Blood as two major components. Which are those? One is the fluid part, which is called as plasma. And the other one is cells part, which is called as formed elements. So plasma is made up of following components, which are those: water, proteins, nutrients, gases, hormones, etc. All these are present in plasma. A major component, almost 90 to 92% of this, it will be having water. Protein forms the next major one. Almost 7% of this, it will be having protein. And proteins are of three types. Which are the three types of proteins present in human plasma? One is called as globulin. Second one is called as fibrinogen. And the last one is called as albumin. Wherein globulin forms what are called as antibodies. And hence you can say globulins are important for immunity function. I'm sure some of you know what is the function of fibrinogen. Fibrinogen plays an important role in blood clotting. Whereas albumin is important for maintaining the osmotic balance. ಜ್ಞಾಪಕ ಇಟ್ಕೊಬೇಕಿದೆಲ್ಲ important. Globulin is for immunity, fibrinogens are for blood clotting, albumin is for osmotic balance. These are the components of proteins. Then you have got nutrients, gases, that is oxygen and carbon dioxide, and different types of hormones. When it comes to formed elements, okay, I'm sorry. Yeah, formed elements, it will be of three types. Which are those? Formed elements will be of three types. One is called as RBC, second one is WBC, and the last one is platelets. RBC is red in color. It is enucleated in humans. It do not contain mitochondria. It has hemoglobin, which is red in color, and it is meant for transportation of oxygen as well as carbon dioxide. WBCs, white blood corpuscles, they are mainly meant for providing immunity in our body. They are broadly classified into two types. Which are those? One, it is called as granulocytes, and the other one is called as agranulocytes. Depending upon type of staining property, granulocytes are of different types. One, it is called as neutrophils. Second one is eosinophils, or also called as acidophils. And the last one is basophils. So wherein neutrophils are largest and most abundant, and hence the answer should be third one. Atyanta eralavagirodu, atyanta doddagirodu, both in size of number as well as size. The answer should be neutrophils, and they perform phagocytosis. Eosinophils are also going to perform phagocytosis, whereas basophils are mainly involved in allergic reaction. These are the different types of granulocytes that you see. Agranulocytes, it will be of two types. One is called as monocytes, which performs again phagocytosis. I hope some of you remember cells such as macrophages, which are present in areolar connective tissue. Phagocytosis ಮಾಡುತ್ತೆ. ಇನ್ನೊಂದನ್ನ they are called as lymphocytes. Again, lymphocytes are divided into two types. One is called as B cells and the other one is called as T cells. ಈ ವರ್ಷ ಓದಿದ್ದೀರಾ human health and disease ನಲ್ಲಿ B cells are going to produce antibody mediated immunity, as T cells are meant for providing cell mediated immunity. So the most abundant cell in our body is neutrophils. Most least cell ಇರೋದು ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ basophils. But basophils ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾವಾಗ ಜಾಸ್ತಿ ಆಗೋದು ಅಂದ್ರೆ when there is allergic reaction in somebody's blood or ಯಾವ್ದಾದ್ರು ಬಾಡಿನಲ್ಲಿ ತುಂಬಾ ಅಲರ್ಜಿ ಆದಾಗ number of basophils are going to increase. Otherwise, the number of basophils will be very, very less. I told you already function of monocytes. Monocytes performs phagocytosis, both monocytes as well as neutrophils. So answer should be second one. And the last type of formed element is platelets. You know, platelets are involved in blood clotting. Clear? So ಇದಕ್ಕೆ answer ಹಾಗಾದ್ರೆ third ಆಗುತ್ತೆ. Very good. Most of you, out of three of you who have given the answer, everybody have given the answer as correct. Fine. Next question. Filtration of blood during urine formation takes place in. You know, urine formation takes place in a structure called as kidney, which are bean-shaped structure like this. So there is two types of blood vessels which enters into this kidney. One is the one which enters, which is called as renal artery. The one which exits is called as renal vein. Now, in the cortex region, outer part is cortex and the inner part is medulla. In medulla, you can see renal calyx like this. Above renal calyx, you can see small pyramid-like structures. These pyramid-like structures which are present above this, it is called as renal pyramid, which is of conical shape. And each of this kidney, it will be having millions of functional units which are called as nephrons. If you look at the structure of nephrons, it will be having first part, which is called as Bowman's capsule. Next to Bowman's capsule, what you see is proximal convoluted tubule like this. Next to proximal convoluted tubule, you can see a structure like this, which is called as loop of Henle. This is loop of Henle. After loop of Henle, you will find what is called as distal convoluted tubule, which will be attached to collecting duct. Now, the blood vessel which enters into kidney, it branches and forms the blood vessel which enters into this. The blood vessel which enters into this is called as afferent arteriole, which further branches like this. Afferent arteriole further branches like this. These branches are called as glomerulus, which will go out of this. The one which is entering is afferent arteriole. One which is exiting, it is efferent arteriole. Please remember the size difference. The one which is called as efferent arteriole, it will be having very small diameter, or lumen, it will be small. Efferent, it will be large, which is going to create pressure inside this. Because of that pressure, the filtration occurs and it passes through. Please remember this. What I am telling, please remember this. it passes through some special cells which are present here. These special cells which are present in the lining of these structures, they are called as podocytes. In between podocytes, there will be small opening. Those openings are called as slit pores, SLIT, slit pores, and filtration happens through slit pores. Out of this, the correct answer should be glomerulus. Correct answer should be glomerulus. In DCT, there will be some secretions which happens, which is called as tubular secretion. In PCT, you can find large amount of reabsorption which is happening, and also some amount of secretion. In collecting duct, you can see concentrated urine which is getting collected. So answer should be glomerulus. Wonderful. So out of those 6 who have answered, all of you have answered it correctly. Next question. Corpus callosum connects the spinal cord with brain, 2 lobes of cerebellum, to cerebral hemisphere, cerebrum and cerebellum. You know, human brain has 2 parts in it, or rather 2 parts. It has got 2 large hemispheres. One is called as left hemisphere and the other one is called as right hemisphere. These 2 large hemispheres of cerebrum, not cerebellum, of cerebrum. ಇದು ಮೇಲ್ಗಡೆಯಿಂದ ನೋಡಿದ್ರೆ brain ಈ ತರ ಕಾಣಿಸುತ್ತೆ. It will be having number of foldings like this which are called as sulci and gyri. So there is one large fissure here. One large fissure here, which is going to divide left hemisphere and right hemisphere. Both of them are held together by a structure called as corpus callosum. So function of corpus callosum is to connect or hold 2 cerebral hemisphere, that is left hemisphere and right hemisphere. So answer should be 3rd one. Yeah, those are the questions which were from 2022, that is last year questions. We still have 30 minutes. Let us start looking into 2021 questions. So any questions, sorry, any doubts as of now? ಏನಾರ ಡೌಟ್ ಇದೆಯಾ? ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ರಲ್ಲಿ ನಿಮಗೆ ಅಥವಾ ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಕಷನ್ ಮಾಡ್ದಲೇ ಬೇರೆ ಯಾವ್ದಾದ್ರೂ ಇದ್ರೂ ಪರವಾಗಿಲ್ಲ. If you have any doubts, please let me know. I will wait for exactly 1 minute and then we will continue with the previous year questions of 2021.
Student, if you have any doubt, put in Q&A. If at all any doubt is there, you can put in question and answer. Prajakta, thank you for your kind support. It's really pleased us. Thank you so much. If there is no doubt, sir will continue with previous year 2021 question paper.
Yes, sir. 1 minute. Yeah. So first question from 2021. Identify the odd one out. So whatever examples you are seeing here, they are from the chapter called biological classification. So under this chapter, you have studied about one kingdom called as fungi. Can you tell me which one is odd one out here? Which one do not belongs to rest of the three examples? Quick answers, only one. So you remember in kingdom called as fungi kingdom, you have studied 5 different divisions of fungi. Those are called as Phycomycetes, Ascomycetes, Basidiomycetes, and Deuteriomycetes. So, 2. Yeah. So out of this Alternaria, Colitotrichum, and Trichoderma, all of them belongs to what is called as imperfect fungi or Deuteriomycetes. They all belongs to Deuteriomycetes, whereas Histilago do not belong to that. And hence the correct answer should be A. Next question. Concept of contagium vivum fluidum. This question is also from the same chapter, that is biological classification. And under this concept of virus, you have studied this. The concept of contagium vivum fluidum was given by whom? Any quick replies? Answer is C, Benjanek. See, out of this, Stanley was a person who first gave or who first crystallized tobacco mosaic virus. So answer cannot be B. Good. I can see many of you answering it. R.H. Whittaker, his contribution is in case of introduction of 5 kingdom classification. 5 kingdom classification was introduced by R.H. Whittaker, wherein he classified entire organisms based on certain concepts or based on certain characters, such as complexity of body, complexity of organisms, based on the body organization, based on nutrition, based on mode of reproduction, and also based on phylogenetic relationship. So based on all this, R.H. Whittaker gave what is called as 5 kingdom classification. Iwansky, on the other hand, was the first person to coin the term virus. Benjamin, what he did was he took an infected tobacco plant, which was infected by tobacco mosaic virus. He took a fluid out of it. And sprayed it on an healthy plant. And he found that healthy plant also developed the symptoms of infection, which means the fluid which was extracted from infected tobacco plant was able to spread the infection to the healthy plant. And that's why he called it as contagium vivum fluidum anta karita. So, see, there is one last question and answers which is in somebody's comment says Martinez. Okay. So answer for this, it should be C, that is MW benzenic. Next question. The plant body having holdfast, stripe, and frond is the characteristic of. When we were discussing about 2022 question, we saw that fungus under plant kingdom is classified into three different divisions called as green algae, brown algae, and red algae. When you see the structure of green algae, first of all, green algae, it can be either unicellular, green algae can be either unicellular, filamentous, colonial. So these are the different characters of green algae, structural characters. Whereas old wax shows what is called as colonial structure, whereas the question is about the entire plant body is divided into holdfast, stripe, and frond. So definitely, old wax cannot be correct answer. This is about green algae. Next, you have studied about brown algae. So all these structures of holdfast, stripe, and frond. I'll just write those structure once. Probably you may remember, or if you are referring your textbook right now, I hope you can recall this. In case of brown algae, it will be having a substrate. You know what do you mean by substrate or substratum? Substratum is the part to which the plant body is attached. Part of the plant body which is attached to substratum, it is called as holdfast. Holdfast in the curriculum. And then there is an leaf which appears brown in color. We have already discussed in the previous year questions that brown algae is brown in color because it contains chlorophyll A and C. Along with that, it contains fucoxanthin and xanthophylls. Because of this, it appears brown in color. So this structure is called as frond. The structure which attaches frond to holdfast, it is called as stripe. So this kind of structures is found on brown algae, and laminaria is an example for brown algae, and hence the answer should be A. Whereas red algae, which will be even more complicated structures, it will be having much more branches and all, but it is in cellular level of organization. Very good. Laminaria is a correct answer. Next question. Answer for this. Yeah. Identify the correct statement regarding class Aves. Class Aves comes under what is called as vertebrates. Vertebrata group. Vertebrata, they are divided into following classes. Which are those? One is species, which are also called as fishes. Second one is amphibians. Third one is reptiles. Fourth one is aves, that is a birds, which is about the question is about. And the last one is mammals, which we belong to. So forelimbs are modified into wings and hind limbs are modified for walking and swimming. Forelimbs anta helidre you can understand it as forelimbs are modified into wings and hind limbs are modified for walking and swimming. You know, in case of birds, forelimbs are modified into wings. All are correct in this statement, sir. Option D. Okay, let's see. Forelimbs are modified into wings, whereas hind limbs are modified for walking, swimming, as well as holding the branches. Heart is completely four-chambered. Heart is completely four-chambered irodu ಎರಡರಲ್ಲಿ ಮಾತ್ರ. Caves have four-chambered heart. Mammals have four-chambered heart. Reptiles have three-chambered heart, which means it will be having two auricles and one ventricle, with one exception, that is in case of crocodile. Crocodile will be having four-chambered heart, which is a reptile, but rest of them it will be having three-chambered heart with two auricle and one ventricle. Amphibians also will be having three-chambered heart with two auricles and one ventricle, whereas fishes will be having only two-chambered heart, wherein it will be having one auricle and one ventricle. So this is also correct statement. They are homeotherms. Homeotherms means they are warm-blooded animals. They are warm-blooded animals, which means they can maintain their body temperature constant irrespective of the ambient temperature. ತನ್ನ ಸುತ್ತಲಿನ ಪರಿಸರದ ಟೆಂಪರೇಚರ್ ಎಷ್ಟೇ ಇರಲಿ, ತನ್ನ ಬಾಡಿ ಟೆಂಪರೇಚರ್ ಮಾತ್ರ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಮೇಂಟೈನ್ ಮಾಡ್ಕೊಳ್ಳೋ ಆರ್ಗ್ಯಾನಿಸಮ್ಸ್ಗಳನ್ನ ಹೋಮಿಯೋಥರ್ಮ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ವಿಚ್ ಅಮಾಂಗ್ ದ ಫಾಲೋಯಿಂಗ್ ಆರ್ ಹೋಮಿಯೋಥರ್ಮ್ಸ್? ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದ್ರಲ್ಲಿ ಹೋಮಿಯೋಥರ್ಮ್ಸ್ ಯಾವ್ದು? Aves and mammals are the only two organisms which shows homeotherms, whereas all rest of them, that is fishes, amphibians and reptiles, are cold-blooded animals. Cold-blooded animals, which means their body temperature changes according to the environment. Their viviparous and development is direct. It is also correct. Yeah. So since all of them are correct, the answer should be D. I can see Shushma Rathod giving the answer as B. Okay, fine. You have given it as D. Correct. Next question. Yeah. Epigynous flower is one in which, yeah, this question is from the chapter called morphology of flowering plants. In morphology of flowering plants, you have studied about the structure of root, stem, leaf, and flowers. In flowers, you have studied the stalk is called as pedicel. It has a thalamus like this. And on thalamus, you can see all other floral structure being attached. If this is thalamus, and all other floral structures such as calyx, corolla, andrecium, and gynoecium. They are present above the thalamus. Thalamus kinta melgade idre. Then you call this flower as epigynous flowers. Epigynous flowers. On the other hand, as you can see in case of guava, ಸೀಬೆ ಹಣ್ಣು ಅಥವಾ ಪೇರಳೆ ಹಣ್ಣು ಅಂತ ಏನ್ ಹೇಳ್ತಾರೋ, in those plants, if this is thalamus, the ovary will be present inside. This will be gynoecium, and you will find calyx, corolla, and rhecium. This kind of flowers are called as ovaries superior and all inferior. This is called as hypogynous flowers. These are called as hypogynous flowers. On the other hand, there is one more type of flower. Wherein if this is thalamus, I'm sorry, I'm very sorry. Please change this. This is hypogynous. I'm very sorry, this is hypogynous. This is hypogynous. Whereas in case of another one, that is perigynous. In case of perigynous, this is calyx, this is corolla, these are andrecium, and ovary, half of that it will be inside the thalamus and the other one it will be half outside. This kind of flower, that is hypogynous flower, it is called as superior ovary. Superior ovary. In case of hypogynous, it is called as inferior ovary. And in case of perigynous, it is called as half superior or half inferior. The question is about epigynous flowers. So ovary is inferior, which means it is inside the thalamus, and all other floral parts are superior, like calyx, corolla, andrecium, including stamen and style. They are all present above this. Only ovary is present inside the thalamus. So answer for this question should be B. I can see Punit Chavan giving the answer as A. I hope it is not going to be confusing. So I just made slight changes here, epigynous and hypogynous. So the answer for this, it should be ovary is inferior and other floral parts are superior. Option A says ovary superior and other floral parts are inferior. It will be hypogynous. This is for hypogynous. All floral parts are the same level, then it is going to be perigynous. Next question, and probably last question for today. Following are the type of cell junctions are not found in animal tissues. Under animal tissue, if we want, we'll discuss about it tomorrow in more detail. Right now, for this questions, for the purpose of this question, animal tissues have been divided into different types of tissue. Out of that, one type of tissue is called as epithelium. Now, while studying about epithelium tissues, you have studied these three types of junctions: adhering junction, tight junction, and gap junctions are found in animal tissues. Whereas one tissue which is not found in animals is loose junctions. No, it is not found. Adhering junctions are the type of junctions which are present between two epithelial cells like this. Suppose if this is one columnar epithelial tissue, and if this is another columnar epithelial tissues, there are certain structures which are called as desmosomes and hemidesmosomes, which are going to hold two of these epithelial cells together. These are going to hold two cells together, or that you can say they are going to act as cementing material between two cells. On the other hand, what do you mean by tight junction is, if this is one epithelial tissues and this is another epithelial tissue, below this epithelial tissue, you will find the presence of many fluid. Those fluid may leak out. So to prevent that leakage, there will be some junctions between two plant cells. These junctions are called as tight junctions. So then what will be the function of tight junction is to prevent, is meant for preventing leakage. And then there is third type, which is called as gap junctions. This is one epithelial cell, and if this is another epithelial cell. Now there is a direct gap between them through which there will be exchange of materials, as well as it is going to help in communication. So this is gap junction, this is tight junction, and this is adhering junction. So gap junction is meant for communication, or it is meant for exchange of materials between two cells. So these three are found in animal cells, whereas loose junctions are not found in case of animal cells. So the kind of junctions that you see in adhering junctions is also called as desmosomes, or there is one more called as hemidesmosomes. Gap junctions is something which I have studied, which is also present in case of cardiac muscles. Cardiac muscles have gap junctions. We have studied about transmission of electric impulse from one neuron to another neuron. During that also, I have studied about electric synapse. Electric synapse also has gap junctions. So with this, I'll stop the class for today, and rest of the question about this paper, we will discuss it in the next class. So if you have any doubts, please let me know. Otherwise, sir, you can continue.
Thank you so much, sir.
Thank you, sir.
Dear students, sir, you will be sharing the material?
Sir, I can share this slides.
Okay, please. I'll share to the students group.
Can I share it tomorrow, like together?
No problem. No problem.
Yeah.
Dear students, thank you so much for attending the sessions. Good to see that you are interacting. And please keep attending till 13th May. 13th May it is going to conclude. Tomorrow also you'll be having chemistry and biology. Without fail, all log in by 3:55. Thank you one and all. Happy learning.